Hello and welcome to DevFest 2020. I'm Jason Titus, VP of Engineering at Google, joining you from my home in California. Each year, we at Google truly feel the anticipation for DevFest. It's a one-of-a-kind series of developer conferences, and we're glad you can join us and the local developers within your community. Your local DevFest event this weekend is one of hundreds taking place all around the world right at this moment. And what makes DevFest truly unique is that it's run by volunteer community organizers on a mission to help other local developers grow and share a passion for Google technologies. Let me introduce you to my teammate, David, to share with you some great examples. Welcome, David.
Hi, Jason. Thank you. And welcome everybody to this year's DevFest season. I'm David McLaughlin, Director of Developer Ecosystems at Google. So I've been with DevFest since the very first year in 2010, when I was able to join a large percentage of them. Back then, they were a series of targeted events in just a handful of countries. In the years since then, we've had massive growth to countries all over the world. I'm happy to be able to continue this celebration of developers and tech in a new virtual format and bring people together to learn and to share what we're all building. Now let's take a look at a really inspiring story from Uganda. It shows how a community member started learning about machine learning and ended up building a really nifty app using TensorFlow that detects diseases in plants and helps farmers reduce crop devastation. Take a look.
Growing up in the city, I never expected to work in agriculture, but when fall armyworm attacked, it affected us all. Since its arrival in 2016, this crop pest has caused massive devastation. I've met farmers who have lost everything.
Tubadde tukozesako ddagala okulaba nti akako okulya ki kasooli. Naye akantu ako tekayinza kumalawo obulwadde obwo ssebo.
So I wanted to use my skills as a software developer to help. At a Google Study Jam, we taught ourselves TensorFlow. We started by building an Android app on top of an open source API. The app allows farmers to spot infestations early, far beyond the capability of human eyes, and suggest an effective treatment. When I was younger, I didn't know what I wanted to do, but then I discovered app development, and I was excited to show people something they never thought possible. Machine learning gives us the advantage against fall armyworm, ultimately saving harvests and reducing pesticides.
Kunkyusizaamu kubanga taata oba jjajja teyalina ennyumba y'ebbaati. N'ebbaati nazimba ennyumba yange nga tetoonya. Tulina essuubi ne tufuna embeera ennungi mu kulima.
We are just getting started, and there are so many other sectors like health and education that machine learning could really improve. Farming is a crucial aspect of life in Uganda, and I feel proud I'm part of a team driving to ensure our culture can continue.
Earlier, you saw a beautiful inspirational video about how machine learning and Android were used to create an app to detect crop diseases. So for DevFest, I wanted to get together a few of my friends from Google and beyond to show you how you could get started in building something just like that from scratch in a few minutes. We'll build an Android app and a web app.
I want to create an app that's able to recognize information about plants. It's going to need camera functionality as well as machine learning inference. Let's see what that looks like in code. The app is written in Kotlin and uses Camera X to take the pictures and MLKit for on-device machine learning analysis. The core functionality is in Take Photo, where we take a picture, analyze it, and display the results. First, we call Take Picture on a Camera X image capture object that was created earlier. One of the parameters is a callback object, which has this on-capture success function. We get the received image into the format we need for MLKit, then we create an image labeler object and process the image. When this succeeds, we receive a collection of image labels, which we turn into text strings and display a toast with the results. Let's see what the demo looks like. So we'll take a picture and it says, I see an insect and a plant. So that was pretty easy, rigging up Camera X and MLKit to detect arbitrary objects in the camera view. But the results were pretty generic because the data set didn't have enough information about our domain. So let's dig a little deeper.
Okay, let's go deeper. Now we need a model for something very specific, detecting diseases in bean plants instead of cassava. Let's explore how to build it. On this guide, we will use some of the great TensorFlow tooling available. Let's start with Colab. You can understand Colab as a cloud-hosted development tool. We will do all our coding on it, and you will not need to install anything on your machine. Let's start with a new notebook. Let's just turn the title to beans. We will need to install some packages that we are going to use later. These packages are not installed on your machine. They are on a cloud machine that was created for your Colab. Nice, it finished installing the packages. Let's download the data and do some visualization to understand how our data is separated. Perfect. We download the data. Let's take a look on some of the images so we can have a better understanding of what we are doing here. Here they are. These are some of the images that will be used for training our model later. Now we have the data. We need to create a model. We are not going to create one from scratch. We are going to use a technique called transfer learning. TensorFlow Hub is a repository for TensorFlow models. You can find all kinds of models here. Let's start with this one. Let's go back to our Colab. Let's define a model handle. Nice. Now we have the data and the base model. How can we do transfer learning? To do that, we are going to use one of the tooling that I mentioned before called Model Maker. Model Maker makes your life way easier when you need to do transfer learning. Let's create the spec for our base model. Let's create our train variables here using the dataset beans that we've just seen. And now we're going to put everything together with Model Maker by defining a model with the training data and the spec that we got from TensorFlow Hub. This will take a couple of minutes. It finished training. And as you can see here, our accuracy is at 87%. Of course, let's evaluate the model with some data it didn't see yet and see how good it is. Nice, 95%.
The TensorFlow Lite model Gus just created contains all the metadata Android Studio needs to recognize it and automatically build classes for it. To get started, you can update your build.gradle file to include the following TensorFlow Lite dependencies. Then, you'll want to import your generated TF-Lite file into the ML folder of your project. Let's check out the details of our imported model. From here, we can see an example of how to use the model in our app. Let's move over to the main activity class to take advantage of it. Inside of our image capture callback, here on line number 78, we create an instance of our model. Next, we use it to process the captured image here on line number 84. And finally, here on lines 92 through 98, we display the results of consuming the output inside of a toast message. Let's run our app. Now, instead of telling us it's looking at a leaf or a plant, it can actually tell us if it's looking at a bean leaf and give a diagnosis. Sweet.
So this concept works, but it's very much a raw demo. What if we want to make this a more successful app? Well, we'd probably need to add services like authentication so our users can sign in, analytics and A/B testing so we can find out how our users are really interacting with our app, some crash reporting or performance monitoring, and an easy way to save our users' data to the cloud. Luckily, that's where Firebase comes in. Now, the new and improved Firebase plugin in Android Studio makes this simple. I'll start by adding some analytics so I can find out exactly how our users are interacting with our app. And the plugin does most of the work to get the library integrated into my project. Now that I've done that, well, we can get an instance of the library up here, and then we can log what kind of results we're getting from MLKit. And then once we've done that, there's a lot of ways to get at this data. It'll start showing up here in the Firebase dashboard, but I find one really fun way of viewing this data is to use Stream View, which kind of gives you a real tiny sample of what kinds of analytics results we're seeing. Looks like I've already recorded several of these select content events, and I can dig into these event properties and see what kinds of results our users are getting. And I could start using that information to maybe refine my MLKit model or A/B test different alternatives. Firebase helps you build better apps, and analytics is just the tip of the proverbial iceberg. Maybe we could let our users upload their own pictures and store them in the cloud using cloud storage for Firebase. There's so many possibilities.
This is a sample app, but if we were to productize this, it's important to keep in mind how our AI design decisions impact our users. For instance, we need to consider if and/or how it makes sense to display confidence intervals to help your users interpret the ML model output. Or say how you design the onboarding experience sets user expectations for the capabilities and limitations of your ML-based app, which is vital to app adoption and engagement. For more guidance on AI design decisions, check out the People Plus AI Guidebook at pair.withgoogle.com/guidebook.
And don't forget about the web. I've built a PWA that can be installed across all your users' platforms. It combines the web camera with TensorFlow.js, and by integrating machine learning, we can make an amazing experience that runs across all browsers.
This isn't a finished project by any means, just a proof of concept for how a minimum viable product with a roadmap to completion can be put together using Google's developer tools and APIs.
You might also want to open source this project too. We'd love to help you with this, and you can learn more about the process at opensource.guide/startingaproject.
Hi, developers. My name is Annie Jean-Baptiste, and I'm the head of product inclusion at Google. The demo you just saw shows how Google's products can come together to create an amazing app. But what about product inclusion? You may be wondering, well, what is product inclusion and why is it important? At Google, we believe that giving power to new voices is the core of innovation. When we bring an inclusive lens to the product design process, we amplify underrepresented voices and allow all users to feel seen and validated in the moments that matter for them. We look beyond ourselves and seek out diverse voices to shape the products that we build. We also believe that we have a responsibility not to disappoint our users, no matter who they are, what they look like, how much money they make, who they love, how old they are, or anything that makes them them. And so when you're developing your own apps, I challenge you to incorporate the principles of product inclusion into the design process, because we believe that you can do well and do good by being intentional about including underrepresented voices at key points in the product design process. Remember, those closest to the problem are also closest to the solution. You can learn more about product inclusion at Google by visiting accelerate.withgoogle.com.
Hi, everyone. My name is Jen Cole, and I'm the Global Developer Communities Program Manager at Google. Now it's time to meet and hear from your local developers. These sessions will cover a variety of technologies, such as Android, Google Cloud Platform, machine learning with TensorFlow, web, Firebase, Google Assistant, and Flutter. Follow @GDG on Twitter for highlights from DevFest around the world, and try out the DevFest AR filter and avatar. Share what you're learning or your favorite part about the event on social media with #DevFest.
Hello everyone, I'm Louisa from the Google Developers team, and I'd like to welcome you today to the very first UK and Ireland DevFest. We're really sorry we can't be together in person, but I know you're going to have a brilliant time with us today, as it's a rare opportunity to get to hear from and interact with developers from across the UK and Ireland and beyond. I'll hand over to Jen now, one of the main organisers of today, to tell you more about what we've got lined up for you. Enjoy DevFest.
Thank you, Louisa. Hi everyone, I'm Jen Ashley, and I'm one of the many GDG leads who are delivering this event to you today. There are 16 Google developer groups who came together to plan and create a wonderful event for you. We are also joined by 2 developer student clubs who have been very active in spreading the word to the student community in the UK and Ireland. I feel very fortunate and happy to have worked with these 29 other individuals to deliver this to you today. Please meet the team. So thank you to this wonderful team, and to you, our attendees and speakers. Thank you for being here, and enjoy the rest of the conference.
Well, hello everyone. I hope everything is going great. Good morning, good evening, or good night, whatever you are. And today I'm going to be your host for the AI/ML track. We'll go through together. Sorry for the beginning. We had a bit of issues with audio, but it's fine. Let's just do a bit of housekeeping first before introducing our first speaker. You could go ahead and go to the code of conduct just to make and read this link just to make sure we're all on the same page, just to basically be nice with everyone in the chat and have fun on the conference. So let's see. Then remember also to add our hashtags. Just screenshot the event and share this with everyone. We'll be retweeting social media, and we also will have great prizes. So let's jump into our first speaker and our agenda. So first, it will be Natalie introducing infrastructure for machine learning applications. Then we'll have the fairness in machine learning, and then so many notebooks and so little time. So with us first, we have Natalie. I'm gonna try to pull her into the stream with me. Hello, Natalie. How you doing?
Hi, I'm good. How are you? Good morning.
Good morning.
And evening and
Excellent.
afternoon.
Yeah, excellent, excellent. Well, it's a shame we couldn't meet in person, but here we are. And we are very excited to hear what your talk is about. And yeah, we're excited to get started. So I don't want to take any more of your time because of the beginning, and I'll let you into continue. If you can share your screen, yeah. Okay.
Absolutely. So I'm sharing my screen and I'm going full screen. And hi, everyone. It's super fun to be here. The opening videos were really great for this track. They mentioned so much about open source and so much about machine learning and so much about specifically TensorFlow. So you have a lot of spoilers for this talk, which is always awesome because hearing something for the second time is never bad. And before we start, I would like to remind that now is October, which means this is the month of Hacktoberfest, and you get to contribute to open source and get some, oh, that's my cat is doing spoilers. You get to contribute to open source and get swag from the Hacktoberfest team if you do 4 open source contributions on GitHub. And all you have to do is 4 pull requests within the month of October. And you are sign up to the Hacktoberfest on the Hacktoberfest website, and then you're good to be qualified to get the t-shirt and all the cool swag. It's really fun to be part of the celebration, especially when this is such remote times. So Hacktoberfest, go for it. This is a security challenge that I was helping a friend with some years ago, and this is basically a screen where you're all familiar with. You just want to hack in there, so you with whatever the pin combination you think is right, all the combinations from 0000 through 9999, and you can brute force your way in, but there is this CAPTCHA there, and that's kind of getting in the way. So what do? Machine learning, right? And part of this challenge was getting the model that this was trained on and then guessing this. So letting the model read this every time and give back the results. So you can actually log in with both fields and manage to hack this. And if you want to see more and what each step means and see all the code, you're welcome to take a picture of this and go to the GitHub repo where the open source code is there and everything is explained. And if you want to read about the details, just go to the upper part where it says the Gopher Academy Advanced blog post. I explained there in a lot of details how to do this really cool thing with TensorFlow and Go. Now, I want to tell you a little bit about myself. I am a Go developer. This is my Gopher person. And I am not a machine learning, I'm not a data engineer, and I'm very curious about this, but I have no official training about this. Most of my knowledge is backend and Go. I studied computer engineering, and everything parallel is what fascinates me. Yet I managed to do this machine learning hacking into this screen with a login screen just with my Go knowledge using TensorFlow. And what I'm here to talk about today is how can you utilize your software skills to do cool things with machine learning without being a machine learning engineer. And if you see anything cool that you like today, please use the hashtag of the conference. Please use the handle of the conference, and you're welcome to include mine as well. It's in the bottom right part of the screen. Our plan for the day is quite a lot. We will talk about how to ML. We'll cover shortly TensorFlow. Then we'll talk about the infrastructure part of machine learning, including an example for a bare bones infrastructure and some end-to-end off-the-shelf solution. And we'll go over a concrete example. And we'll recap if time allows, Q&A. If not, you're always welcome to ping me on Twitter. What is machine learning? From Wikipedia, this is the study of algorithms and statistical models that allow a system to perform tasks just relying on patterns and inference. And what's interesting is that this is a subset of artificial intelligence. So what is artificial intelligence? Well, many things. The definition from Wikipedia is that this is intelligence demonstrated by machines, unlike intelligence demonstrated by humans. And this is, the intelligence is used to do all kinds of cognitive functions like learning and problem solving. Pretty cool. How to ML? Generally, these are the steps. You start with defining the problem. Do you want to recognize text? Do you want to say yes, no? For example, if this is something medical, does this look like disease or not disease? And you define also how many outcomes you have. For example, if you're doing digit recognition, it's 10 outcomes. If you're doing text recognition, then you have about 20 to 30 characters. If this is a Latin language, if this is face recognition, you can have millions and so on. Then you gather the data that is relevant to the task, and you prepare it by cleaning, by centerizing it and randomizing it, and mainly splitting it into 25% and test data that will be used in the end, and 75% of the data will be used for the training. And then you choose a model. The model choosing depends on the learning task, the type of the input, and number of categories. And then once you have a good model, you train it by assigning random values and just doing a lot of iterations, every time adjusting the weights. And then you take the remaining 25% of the data and you do evaluation to the model. Here, usually you would land back to either step 4 or 5 until you're happy with the result. And then you move to step 7, where you fine-tune the higher parameters. And then once you're all done with everything, you are ready to predict. TensorFlow. Now, the last 15 minutes of the intro, we're covering many cool things about TensorFlow. So I will just add to that the reason that TensorFlow is called TensorFlow is that it takes data that is represented as tensor. This is how a tensor looks. And a tensor is defined with 2 things: the data type, for example, integer, and the shape of it, which is number of dimensions, the number of values per dimension. And that data piece is flowing through the graph. The graph is aka the model. This is a representation of the mathematical representation of the model, let's say. This is a set of nodes. Each node is a mathematical operation. And this data that is flowing through it is undergoing mathematical manipulation at every step of the graph. So at every node, you can look at the intermediate result. And the final output is the outcome of your model. So that's why it's called TensorFlow. Hope that makes sense. The reason I really like TensorFlow is that it's community-driven and that it's becoming friendly for developers. There are all kinds of tools to support that. For example, AutoML. This automates the machine learning design altogether and basically lands you pretty much ready to predict. There is the TensorFlow Hub, which is a repo for modules from which you can pull a module for whatever task you need. And then you have to do the training. And you have all kinds of tools that are built on top of TensorFlow, the beauty of open source. And then you have solutions that are basically ready to do the prediction you need. Okay, so we talked about machine learning. Now we're here to talk about the infrastructure of machine learning. Let's talk about that. This is a really great article that was written 5 years ago by a group of Google developers that were talking about the problem of quickly hacking up the infrastructure around the machine learning model, which can happen many times because there's still not many good practices around how to do things, and a lot of the focus is the machine learning model itself. The short version is that there's a lot more to machine learning than just implementing the algorithm. Actually, the code around the algorithm is about 5% or less of a production system. The rest is all supporting modules like the configuration, the data verification and collection, the resource management, the serving, the monitoring, process management, and whatnot. See the black box in the middle, the small one? This is the part of the code itself. Let's take a deep breath. For now, we're gonna go even a little faster just to cover all the important and interesting things. Apache is a great tool for machine learning, and it's composed of subparts, and it's all open source, so you can choose whichever part of the Apache toolbox, if you will, you can use for your project. And it is told that about half of the Fortune 500 companies are using some of the Apache toolbox, the Hadoop toolbox, just because there's so many great things there to process big data. Now, this slide is pretty tricky. It's like comparing apples to pears or even to apples. So take the next slide with a little bit of a grain of salt, because it's very hard to make a generalization, but it's really helping with understanding. Apache Hadoop is a type of a data lake platform. A data lake is a definition coined by James Dixon, and it says basically this is a way to store a lot of data in the raw shape of it, unlike a database, which is storing the data in the structured way. Those are some of the popular data lake platforms out there, and again, I want to remind that this is comparing apples and pears to papples, so this is a little tricky, but this is a general first good understanding. This one is more straightforward. Database is the next part of a machine learning system, and here are some of the databases that are used out there. It's worth mentioning that all the tools you'll see now are mostly open source, and all are definitely supporting the Go programming language, because we want to learn how to build infrastructure using Go. Next, function as a service or serverless. You can use AWS Lambda, you can use Azure Functions, Google Cloud Functions, OpenFast, and several other tools. And then the next step is the data governance. Now, probably this is the term that is less familiar to most of you from all the different components we've seen so far. And data governance is the part that is handling data. For example, you are receiving credit card information, but you don't have PCI compliance, then filtering it out before it comes to the system or hashing it before you store it is a type of data governance. Another type of an action that is data governance is separating the data. So part goes to the data science team, another relevant part goes to the ops team, for example, because the ops team doesn't need to know the, let's say, the cities of all the users that you have, but the data science would need that to help to do clustering and so on. So breaking down the data by teams and giving the accessibility to the sub part of it is considered data governance. And these are some of the companies that are offering data governance. Next up, we have a great part, which is the monitoring. And of course, you want to make sure your system is functioning properly, so you need monitoring. And putting it all together creates for us a bare bones infrastructure. So let's say we have a set of data files from different formats: Parquet files, JSON files, and CSV files. First of all, we're doing a first round of data governance. So let's say we're filtering out credit card information. Then we're storing it, our data. One time we're storing it in the raw shape in the data lake platform of our choice. And then we also put it in the database. Each type of data storage has pros and cons. The data lake allows you to store the data in the most raw shape, which means that you cannot lose information. But the cons is that it's hard to access sometimes because each JSON and the Parquet files are pretty different from each other. On the other hand, the database, you know how to access it. There's an API, it's very clear, but you filtered out some of the data because you wanted to fit in your database schema or structure. Next, you're doing a second round of data governance. So let's say break down data by the different teams, whatever access each team needs to have. And maybe you even want to put some of your data in, anonymize it maybe, and put it as a open source data that people can use for their open source projects, or if they want to train a model, or if they want to learn TensorFlow. Then you take your data and you do the model training. Let's zoom in on that a little bit. This is landing us at stage 5 of How to ML. And there are roughly 2 types of training: offline, static model, and a dynamic model, which is done online. Each one has pros and cons. The static model pretty much means train offline, train everything on your computer, on your machine, and then upload this. Of course, the big advantage is that it's easier to build and it's very easy to test, but you can only predict things you know about. And the update latency can be really long because you're going to retrain on your whole data set, and then you're going to upload everything. And of course, you cannot allow to use a model that is half on the old updated data and half on the new trained data. On the other hand, we have dynamic model, and the big plus of it is that it is adapting to the changing data. So it's basically a feedback loop, and it's more likely to make better predictions. But because the predictions are made live, you have to put limitations on it, which will affect the performance because it can be very compute intensive or latency intensive. And of course, you need to monitor the whole thing, that you want to make sure that this is not timing out, taking reasonable time, and even giving reasonable results. Okay, so we have this much of our infrastructure. Then, of course, comes the serving. Serving is also called inference and basically gives us the output. And let's zoom in on that as well. So this is the last stage of How to ML. And this one can also be broken down into the 2 parts, or into the 2 types of online and offline. Online, it can make predictions as new items come in, which is great in long tail, which is really great for retail, because an example that I like to give is the flower shop. Let's say your flower shop is using a data model that helps you plan how many flowers you want to pre-order every day for the next days. And then you know that during the week you're selling this many flowers, and then during the weekend you have slightly more, so you maybe order 20% more. And then comes February. February 10th, February 11th, there is a slight increase. February 13th, even more increase in the demand, and you're suddenly selling out. If your model is doing offline inference, then it will say, well, it's the middle of the week, so just order as many flowers as you have ordered. But if this is an online inference, it will notice a trend in the increase in the demand for the flowers. So it will tell you, I'm not sure why, but order some more flowers. And this way, you find yourself on Valentine's Day not selling out, but actually having enough demand and supply for that demand for the most profitable day of the year, probably. Of course, the downside of the online is that, again, it's compute intensive and latency sensitive, so you will put limitations and you will have to monitor. On the other side, the offline model, you don't need to worry about the cost of the inference, and you don't need to do post-verification, or you can actually do post-verification because you will never get weird results because you can see all the results ahead, so you can actually check them. And the con, it can only predict what it knows. So this is our model so far, and we have the really interesting part of monitoring, making sure that the system is actually working as expected, the connections to the database are not timing out, you're not saying that every result that comes, every input that comes to the system is, let's say, false, whatever the equivalent of false in our system is, but only the dedicated % of it is, so it's within the reason boundaries and so on. Monitoring is super important. And this is how I see the bare bones infrastructure of a machine learning application that can be used in production. On the other hand, this is the ecosystem. There are so many subfields that are not included there, but can be useful, whether it's all sorts of databases, whether this is data integration, data transformation, storage, cluster SVCs, AIOps, or even search, visualization, of course, security, and so many, many more. So this goes to show that there is the bare bones, which is what you need to start with, and then you can make a lot of adaptations to whatever your specific product needs. Then there are end-to-end off-the-shelf solutions. Of course, TensorFlow Extended, for example, gives you the entire thing from beginning to the end. So from creating examples through making sure that they make sense statistically, to training the model, to serving it. And as mentioned also in the opening slide again, TensorFlow can be regular serving, so on the web, but it can also be light, for example, on mobile embedded devices, and many other options out there. And let's look at one concrete example of an infrastructure system for machine learning that is actually used in production. And we will look at the fraud detection system. So there's a website that tells you whether your online purchase is a fraud or not. And this is a service that that companies are using, sending their data from a transaction in their shop. And the response that they get, fraud, not fraud. So basically, should you approve this purchase or not? The input is the user ID, the seller ID, the item ID, and the credit card hash. And this all goes into the database. And then it's being enriched. Enriched means that this is, those 4 data points are turned to thousands of data points. For example, how long the user has been registered, how many of the user purchases were reported as fraud, and so on. And each question gets a numerical value between 0 and 1. And this is creating this input feature vector that is then being fed to the model just as a set of numbers. And then this is output of the model is fraud or not fraud. And then they respond this back to their client and saying you should approve or not approve of this purchase based on the current threshold, because a machine learning model also outputs a numerical value. And the fraud value is also a dynamic threshold. So depending on what the current number is, so we still remember online model, then based on that, the fraud is being decided as a fraud or not. And on top of everything, of course, there is monitoring going on. Whew, that was a lot, wasn't that? Let's recap. What is AI? What is ML? How to ML? This is how we started our slides. Then we saw this really great picture that I found on the Twitter feed of the user, the Alex Freeman, and it covers what is AI, or some parts of it to give you a bigger picture. Then we discussed TensorFlow and what's so great about it. TLDR data is represented as tensors, which flow through the graph, which is the mathematical representation of the model. Each node is a mathematical operation. The data undergoes mathematical manipulations while flowing through the graph. Then we talked about types of training and inference, online and offline. So there's pros and cons to each. Then we looked at one bare bones architecture example. It was this. And we saw that on the other side, there's a lot more to add to that. And we talked about one concrete architecture example. This is a system that is being used in production, and it tells you fraud or not fraud for online purchases. And it does it, of course, really fast because it has to meet the specific SLAs of all the different clients, because when you are buying online, the last thing you want after you type your credit card data is to wait long. So we're talking about a few milliseconds here. And if you should take 3 things from this presentation, it will be all in this slide. Take a moment to focus on it with me. I know it's been a lot of data. Machine learning code is about 5% or less of the overall code of a system. The rest is all the infrastructure supporting modules. The input data is a big and tricky part of the machine learning system. And one example of a bare bones flow of such infrastructure is to process the data, store it, use it to train the model, serve predictions, and monitor the entire system. And if you liked and learned anything here, please share on social media. The hashtag for the DevFest is #DevFest. Thank you very much.
Thank you, Natalie. Amazing. Thank you so much. It was very, very interesting. ML, you know, we all love ML. So, okay, it's great.
Thank you so much for having me.
Yeah,
Great DevFest.
Yeah, sure. We'll all be having fun with it. A lot of lovely comments. So yeah, thank you. Bye. Well, we now will introduce our next speaker. I think she's already here. Let's just bring her in. Hello. Good morning. Can you hear me?
Yeah, I can hear you.
Okay, excellent. We can hear you as well. You're live now. So yeah.
Charmi will be joining the workshop in the evening, so she could not make it in the morning talk. So I will be covering the talk.
Okay. Yeah. No worries. No worries. You have it all under control, isn't it? Yep.
Yeah.
Wow. Amazing. So I just won't take you any more time from you, and I'll let you do your magic.
Hope you can see my screen.
Yeah, your screen should be up now.
Right. Okay. Let me start. So today's agenda is designing fair machine learning models. And I'm Sharmistha here. I'm an author, speaker, and a MLGD. And I'm also an active blogger. You can follow my blogs at takeairesearch.com and all the fairness talks that we have it today and the workshop in the afternoon. All the code is available at GitHub Sharmi 12806. So let's start. So what are the key takeaways of today's session? So we try to look at why do we need fairness, and especially in the context of ML. So then we go and try to ask the question, what is fairness and where did it originate? Followed by some examples and demonstration. But last but not the least, we should also see that how do we build fair machine learning models with TensorFlow, a library which has been released by Google. So we'll also see the TensorFlow constraint optimization library. How do we build deep learning models like CNN, CNN by LSTM, LSTM, BERT? How do we integrate those models with fairness constraints? So what do you see? Let's have an eye test. So you might be saying that bananas, yellow bananas, bananas on the shelf, or bananas with sticker, right? So we always have a thought that is associated with us that bananas should be yellow, or maybe bananas are green, or unripe bananas. So what is the thought that we have when we see the black bananas? We think that these are overripe bananas. Bananas good for bread. So the very thought of bananas gives us a yellow impression in our brain, that banana is prototypical yellow in color, or it is green in color. And that's how, if we think, if we get a banana which is brown in color, obviously we don't think of that the banana could be brown or a banana can be totally black. We always have thought of that from our childhood, that bananas are yellow, bananas are green. And then do we see that, is it fair? How do we have the perceive or thought of any object that is always registered in our mind? Is it always correct? And that's how fairness comes in. Let's see. Why fairness? Why there has been so much initiative in the machine learning research field that we take into fairness in different ML models and in different industries like hiring. Why? So we have seen that there has been housing fair acts, like where people of race, different color schemes have been discriminated. People have not been allowed to rent properties. People have been denied buying new houses. Only residents or the people who are residents of the country or the citizens have been given housing first. There has been LGBT Fairness Act, so that people of different LGBT communities are treated fairly. There has been the Disparate Impact in the US. There has been Disability Status Acts, so that disabled persons who are capable are given fair opportunity in jobs. So all these things are given us have a direction to look at things in a different angle, that are we doing a fair job to everyone in our society? If are all the eligible people are getting fair opportunities, because that's the good for the society. And then let's see what is fairness. In the context of machine learning, a given algorithm is said to be fair if the results are independent of a given variable, especially those protected or sensitive attributes. What are those attributes? It could be like gender, ethnicity, sexual orientation, or disability, so that a male or female has an equal opportunity to get jobs, or they are treated equally when they are submitted the CVs. They get equal call when they have submitted their CVs. Ethnicity, race. So in a country like India, we have a lot of different religions. Also, within each religion, we find different sectors, like we have forward classes, backward classes, OBC, SC/ST. So everybody, are they getting a fair chance in the positions they deserve? Sexual orientation, it can be male, female. Like gender, it can be like gay, straight, lesbian. So everyone, are they treated equally? Or disability status, somebody may not be able to walk properly, somebody maybe may have some problem with the hands, or speech, or hearing problem, but they are very capable. Are they getting a fair chance? So that's how, when we model any machine learning problem, we should take into consideration that those demographic attributes or those protected sensitive attributes are not disclosed to the point it is necessary, or we don't take those attributes while training our machine learning models, so that the outcome are not dictated or governed by these sensitive attributes. The outcome should be independent of these sensitive attributes. Now let's look at that. How did it originate? What are the research that professors have undertaken? So Professor Klaus Schwab is one of the executive chairmen of World Economic Forum. He also always stresses the importance of ethical AI, and that is left up to us. How do we design it in terms of design and use it in biotechnology and other significant areas of life? So that's how fairness has originated, from these eminent figures, that they have stressed that ethical AI is a very important thing. We can't keep on building machine learning models that are very highly accurate. It can be highly accurate because there are more population which are normal, like which do not have sensitive, which do have sensitive and protected attributes of minority groups, which are very few. Like female are very few. The black colored people are very few. The minority groups are very few. We have to build machine learning models for all. And that's how the Algorithm Justice League has been formed from Joy Buolamwini, computer scientist and digital activist from MIT lab. So she stresses on the use of artificial intelligence to black-skinned people as well. So it has to be fair, not only for white skin, but the skin tone of when it is Asian, Hispanic, or when we have black-skinned people, when we do computer vision, when we train images, that has to be fair for everybody. Otherwise, we will lose the civil rights and gender equity. And that's how we see that's the machine learning models have to have a fair proportion of black-skinned images in the training data. Because otherwise it is giving high accuracy for light-skinned men, and for dark-skinned people we are seeing rise in error rates. The error rates increases up to 20 to 34%. Then we are not fair. We are not having an equal society for everybody. And now let's see, how does this biases creep in our system in machine learning models? So bias can creep in right from the stage of collecting data, labeling data. And then once we have labeled the data, we are training a supervised model. We have this hyperparameter training and training the metrics and the objective function. We label the data, and then we have a set of target variables and a set of training input variables. So everywhere that biases can creep in, the human bias. and then we filter and rank and aggregate the data, or we define the precision, recall, and the classification metrics, we can see that there is human bias that is affecting our ML models. So we need to be very particular from the data set, right from the start stage of collecting data. Are the data diversified? Are we capturing the minority groups sufficiently so that the model output is not biased against them? And having said so, what are the types of bias? So group attrition bias, reporting bias, automation bias, selection bias, and implicit bias. So what is group attrition bias? You can see in the figure below, there are a bride and the groom standing, and most they have us fair-skinned people. This first one, third one is the fair-skinned people, and this one, the second one, and the fourth one, they are also bride. The second one is also bride, and the fourth one is also bride and groom. But the model is built in such a way it will identify fair-skinned people, and when there are two of them standing together in a white gown. But this one is also a wedding dress. A girl is wearing a wedding dress. She's also bride. So the model is not able to identify, because it is taught that only when two people with and the girl dressed is in white and the guy dressed is black or white is a bride and a bridegroom. Similarly, the right hand side also, they are people for different ethnicity, but we have not trained them with enough images of minority groups. That's why we see group attrition bias. Then reporting bias. We always see that whenever we are buying something online, or when we are availing any services, when we are very much satisfied with the product, or we have a very negative review of the product, we give a reporting bias. We have a reporting bias. But when we are just neutral opinion, we are not filling up the survey forms. That's how reporting biases creep in. Automation bias. So when there are automation machines, it's on the machine side, machines like IoT devices that are capturing. So if there is something wrong in the system, as like the base range of temperature or base range of pressure changes, if you are not updating the machine, then there will be automation bias. So we need to be very careful that what we are reporting as the baseline or the model data is always tuned and updated whenever there is an event or change. Selection bias. And selection bias or implicit bias, it comes from our mind, as we have seen the yellow bananas. So whenever we think of, we put it on Google Translator, like a nurse, and Google Translator will always give a picture of a female. We can't think that a nurse can be a male also. Similarly, if I ask you that what do you think as an air hostess, what does it come in your mind when you think of an air hostess? Can we think of a guy being an air hostess? No, automatically the first thought is to us is a lady who is taking care of us in the airplanes. So these are selection and implicit bias which are coming into our mind because we have been taught by this. We have seen things over generations, and that has crept into our mind, unconscious bias. And now let's look at how does bias affect AI system in various domains. So we will see bias in healthcare. So suppose, as we have talked about, if we have trying to use computer vision and trying to identify skin cancer. Now, if you're feeding the model with data of light-skinned people, it will obviously not able to identify skin cancer or skin disease for dark-skinned people. So our model should have a fair proportion of the dark-skinned people also. In hiring, we see that when we disclose the names of the persons, like they are male or female, it is very unlikely that the women get equal amount of call in the interviews like men. Mostly when gender with male gets a high selection ratio for interview calls. And that's how it is seen here. If you see the last one, the brand strategist, it's a female, but she's ranked 10. Why? There's no reason for her. Because she has education experience of 102 years. She has a work experience, means the woman categorized work experience is 220, but still she's ranked at 10. So that's how the biases in hiring creep in. There are biases in finance. There are biases in law. Like when we have seen that in US especially, that the criminal investigation reports suggest that if the black people are accused more, they are likely to face charges and accusals because they are black. They are black Americans. Education, fashion. So in fashion, if we see in 21st century, the true beauty comes from inside. But whenever I put an app, Android app, and try to put my picture and see how do I look at it, it will try to discolor my skin and put it more fairer skin. Why? Because it doesn't make any sense. Today's 21st century true beauty comes from inside. There's no reason for us to change the color of the skin and think that it is more fair and that's why it will look good. That's how biases in various domains affects our machine learning models. And if you look at a very practical example like Uber, the black-skinned and especially if the female drivers have been found to receive a very low rating that has affected the wages compared to the male counterparts. And also female drivers have experienced 47% more serious car injury because female body type crash dummies weren't required by the US Department of Transportation. So that's the reason that we ignore the minority section of the population and design models which are biased and affect our society. So it's ultimately we are ending up in car crash. And now what Google suggests, what are the best practices for removing bias? So we should have a clearly defined product goal roadmap. And that has to be identified and carefully reviewed from the stakeholders. There will be multiple stakeholders. We should carefully review the product goals. And if we see there is risk in any groups, we have to identify what are those risk groups, what are those sensitive protected attributes, and mitigate those in order to bring fairness. And of course, every time when our model predicts, we should analyze the results, build a transparent system of reporting, evaluation, and monitoring. So all the results, what are happening to each and every individual belonging to different communities has to be monitored, and evaluated with performance. And if we see there are issues, we should escalate. So there comes in the what if tool. So because we are going for the TensorFlow example, or the what if tool we will also cover in the workshop during the afternoon. So that's how we should ensure the best practices of removing bias. And what does Google's responsible AI suggest? We should have an inclusive society. We should include race, nationality, and religion from different parts of the world. We should have diverse identities within the same country, within the same culture. We will find people of different backgrounds. We should include those data. We should also include social science and backgrounds, their thinking style, thinking pattern, somebody who has been brought up in a different environment. We should include their thoughts. Somebody who is a single parent, we should consider their view. Also, and gender and sexual orientation, that comes again and again. So these are very common, gender and sexual orientation, but we should also think of other parameters which can create a diverse opinion. And of course, we should seek expert opinion every step. User researcher, fairness experts, legally, are we doing what we are developing is legally correct, ethical. There should be privacy experts. We should review that with the privacy experts and the fairness experts, because the ultimate goal is not to only build a fair system, but we should not leak certain sensitive attributes to the outside. Like certain sensitive attributes, people may not want to reveal their sexual orientation. So the goal is to have all those experts take their opinion and build into the system. And let's go and look into some of the code examples with the TensorFlow. So we have this, we have taken data from Kaggle's Jigsaw Puzzle, which is like a conversational AI kind of a platform that has a conversational AI which has a lot of wiki comments. Like it has different groups, like it has comments related to gender, sexuality, religion, race, mental, physical, and economic condition. So we try to pick those terms. And why did we try to do this? Because in gender, male or female will be coming more often. But what about transgender? What about people who don't want to reveal their gender? What about sexuality? Same thing with religion, race. There will be some of those religion and race, mental and physical conditions. We'll see in the following slides that there can be very minor proportions in each of these groups. And we try to identify that how we can build such with constraints in the model that we are also able to identify those very minority subgroups and the minority labels. So that's why what we did is we took the data. It's a huge data, around like a 50 MB file. So we tried to split it up in terms of training, validation, and test data set. And then we try to import this TensorFlow constraint optimization as TFCO. So here the TensorFlow normal libraries like TensorFlow 2.0, TF, Keras, layers, sequence, and text for doing normal NLP related stuffs. And then we have the model, the dense layers, embedding, bidirectional, global max pooling for building different kinds of CNN and different kinds of LSTM models. And what kind of optimization did we use? We used proxy Lagrangian optimizer. So previously there has been a use of Lagrangian optimizer, but that did not serve as an efficient solution, especially for stochastic gradient descent and for deep learning problems. So Google came up with a proxy Lagrangian optimizer, which is known to give M+1 deterministic solutions for M constraints, and especially it's more useful for SGD, like stochastic gradient descent, where we can set up constraints on false positives or false positives and false negatives on both. And these constraints are non-convex and non-differentiable. But one major limitations currently this library has is it doesn't support multi-class classification. So Google is working on it. So we'll see a binary class classification problem here. And when we think of multi-class, in few months, we hope that Google will come up with that. So as we have talked about that different groups, now let's look at the mental subgroup. So mental subgroup may have different kinds of problems that people may be facing. Like some may be suffering from depression, anxiety, schizophrenia, all those groups. And this is the subgroup proportion. Like within this group, like the mental depression, how many people are suffering from different problems? And this is the label proportion, means out of the total population, how much of the depression patients are there. And then how do we try to optimize the problem? Like we take half of max of overall false positive. Overall false positive means the entire population, comma, the false positive of a subgroup. Like it can be mental health condition, sexuality, or any subgroup, plus half of overall false negative followed by the false negative of the individual group. And that's how we set up the rate context. And on the context and the rate context, we introduce the predictions sensitive attributes. And then we add the false positive, false negative constraints. And once we have added that, we define that how much percentage of tolerance is there, like we are allowing 50%, 0.5. And then we set up the proxy Lagrangian optimizer and pass it with the rate minimization problem. And we have the trainable weights and all. These are normal deep learning parameters. So let's look at how does it behave. So you see that the bidirectional LSTM has this 74 close to 74, while CNN has close to 81% of accuracy. While BERT, we did it on a limited set because BERT model itself takes a lot of time for training. And with fairness constraints, obviously the time of taking it is much more increased, and we should have sufficient GPUs or TPUs to carry that. And of course, since we have done it for BERT, we can extend it for any kind of transformer models like GP2, GPT, everywhere we can introduce fairness. Advanced model in chatbots and sentiment analysis, so that we are fair in detecting the negative and the positive sentiments. And one of the most important thing what we should not fail to notice is that the accuracy gets sacrificed when we introduce fairness constraint. So accuracy will get a hit. And so the business has to define that what is the acceptable trade-off that we can accept or we can compromise on introducing fairness Why? Because it will get the accuracy will suffer a hit. So I'll show you that unconstrained model will have almost 90% accuracy, whereas that the fair models sees a sufficient degradation in terms of accuracy. And as we go and talk about AI, ethical AI, and we should not forget that the regulations have been becoming more and more strict. So as Sundar Pichai stresses on AI regulations, that we have to build fair models for everybody, for fair marketplace, for building recommendation systems. So producer consumers should see a fair model. So producers and consumers should get a lot of variety of items recommended, that especially the consumers. By the producers, there should not be any monopoly. Everywhere, every producers who are new in the business should be allowed to enter the marketplace and have a fair chance of getting their items introduced into the consumers. There are legal obligations. There are social responsibility. We cannot ignore the minority section. We have to be fair towards them. And of course, the business requirement. If we see a fair world, of course, our business turnover will increase. Having said that, let's go and see just a Jupyter notebook in last few minutes. And this is how we build a fair model for everybody. And last but not the least, if we talk about fairness, as we have discussed, we should have diverse data from different sources. And when we do the collect data from different sources, some individuals may not want to reveal some of the parameters. So the job doesn't end at building fair models. We have to be sure that we are able to build a fair and a trustworthy systems. So it's a kind of ensembling modeling. So build minor data sets from different models and take different data sets from different and build different models, ensemble them, add noise, because many individuals would want to mask their sensitive attributes. We should respect them. So mask different parameters and build an assembled aggregated model that is both fair and private. And that's how we incorporate a trustworthy AI system. It should be secured, it should be interpretable, like that we should be able to explain with what if tool that why there is a minority drip. If we have predicted something and the minority community is not performing well, we should be able to explain that there is not sufficient data for the minority community. That's why we see a model performance dip. We are not able to identify the black-skinned people. Everything should be explainable. So that's how we build a trustworthy AI system. So we take into diversity into consideration, we avoid discrimination. That's for the well-being of the society as a whole. These are some of the references. And let me show you a little bit on the Jupyter notebook. So here in the Jupyter notebook, you will see that we have taken all the imports, the hyperparameters, the normal LLP, and then we have, after we have splitted the data, we have built, these are some of the terms. So sexuality, what are the terms we have taken? These are very less terms. These proportions are very less. Gender equity, religion, mental, economic condition. We have defined the groups, and then what we have done is we have shown you on the PPT just the unconstrained model. So these are different kinds of error rates, false positive, false degree. It's up to you. How do you want to add the constraint? You want to add on precision recall, you want to add a precision at recall. We'll all cover in the workshop. I won't take much time. And that's the unconstrained model, has 93% accuracy, 94, close to 94% accuracy, whereas the constrained model which we have built has a drop in accuracy. So it is like 81%, but the false positive and false negative rates are much lower than the unconstrained model, because we have built a constraint on this. And how we have done that, we have two mini batches. One mini batch is for the entire population and one mini batch for the groups, because otherwise we will lose the minority groups. Okay, that's how I end it, because we are running out of time. Questions?
Awesome. Thank you so much. Yeah, so it is we see some people on the comments. Rare presentation from you, so amazing. Very important topic, I think, in machine learning. Bias, fairness, and diversity is something that needs to be organized, because data is very unorganized. And yeah, really, definitely something we should look more into. And we really liked your talk and appreciate you showing us the way in which we could fix that. So amazing.
Thank you. By end of workshop, we'll have a detailed go through to the course. So anybody interested in the workshop at 3:15 London time, I think 3:45 or 3:15 London time, can join me with Charmi. We have a 1.5 hour session. We'll go through the what if tool. We'll go through the code more slowly so that we are can build a more equal society with
Amazing.
ML.
Amazing. Thank you so much. Well, looking forward to it. Thank you. Okay, so our next speaker will talk a little bit about notebooks. Very important for machine learning and data science. Jupyter notebooks and our main tools for building amazing models. So here it is, Mark. You join me in the stream. How are you doing, Mark?
I'm fine. How are you, Ricardo?
Excellent.
Nice to see you
so
this
I
morning.
see. Yeah, nice to see you. I see you have a nice little setup, nice mic. So this talk looks very exciting. Looking forward to it.
Cool. Shall I begin then?
Yeah, you can start sharing your screen.
Let me share my screen. So hopefully you're seeing a slide, which I'll go into present mode with. And
yeah, there you go.
Can see it okay, cool. As Ricardo said, I'm Mark Cohen. I'm a developer advocate at Google for the cloud. I do spend most of my time on data science and machine learning products and services. And today I'm going to talk about notebooks specifically. So I was happy to see in the last talk we had an example of that. And you probably have seen or will see others throughout the day today. This talk is a collaboration with my friend Lori White. And all the slides you see here today are available through the URL that you see at the bottom here, mco.fyi/nb for notebook. I love puzzles, and so I've put one right in the first slide here. The problem is to figure out what goes into this bubble with a question mark, and I'll just warn you that the answer that seems most obvious is wrong. It has nothing to do with the talk, but for those of you who enjoy puzzles, feel free to take a crack at that one. I want to start by asking a question. What's more exciting nowadays than artificial intelligence? It seems like it's dominating all of the headlines, all of our attention, and so on. And my answer is human intelligence. And what I'd like to talk with you about today is really a class of tools that allow us to apply computers and software to improving how humans learn, which I think is really exciting. The class is called Jupyter. I'm sure most of you know about it, but what I want to specifically talk about is how to use Jupyter in production or in an environment that's easy to get into, easy to share, easy to take advantage of. And I'm going to walk through 3 specific examples in the Google Cloud and finish up with kind of a summary of some guidance. So first of all, what is Jupyter? And apologize for those of you who already know. Probably a lot of you have used Jupyter, have maybe authored your own notebooks. But for people who haven't seen it before, it's an interactive tool where it's essentially a document where you can have a live code in the document and you can execute the code interactively. You can edit the code and the text. It takes markdown format for the text cells. Just a very flexible tool for explaining things and for giving people direct experience with technology, specifically coding. And one kind of key feature of it, in my view, is that the authoring interface and the user interface is the same one. So it's really simple. I go visit the notebook if I'm the creator, and I can freely edit the cells and change them. I can share that link with you. You can go in and you'll see almost the exact same interface, except you won't be able to edit it if you don't have permission. But other than that, we'll have one unified experience. And the authoring is quite nice. It's essentially what you see is what you get type of interface. There's no coding. For the interface itself, you'll obviously put code into the notebook. So the first example of a great way to use Jupyter is called Colab. And the sort of tagline here is it's free, zero friction notebooks hosted by Google with a Google Docs model. I have a couple of examples here by way of demos. Just to protect the time slot here, what I'm going to do is just give you pointers to the demos, and then if I have time at the end, I'll come back and we'll visit each of these, as many as I can get through. And just I may not get through any depending on how fast I go, but I'll do my best. But I didn't want to get bogged down up front with diving too deeply in a demo. The first one here is a notebook I've been using for a Python course I teach on my own. And it'll give you a sense of how to use an example of a way to use a Colab notebook in an actual classroom type environment. The second one is a fun model using Keras to build a digit recognition machine learning model, and the MNIST recognition model. And with that notebook, you get to actually interactively try the model out in real time, which is kind of fun. Just a quick summary of features of Colab. As I mentioned, it's hosted and served by and managed, of course, by Google. It's minimal friction. So I can give you a URL like the two on the last slide. You can click there and you're in the notebook. You didn't have to do any work. You didn't have to set up a Jupyter server or Jupyter Hub or any of that stuff. You don't even have to know anything about Jupyter. You can just start interacting with the notebook immediately. The other nice thing is you don't actually need to sign up for any service other than having a Google login, right? So it's essentially like the Google Docs experience, only brought to notebooks. There's some nice features where you can kind of combine the notebook you're viewing with Colab. You can click on a button in GitHub and it'll take you right from your repo to open the notebook in Colab. There's a Chrome extension you can use to go directly from viewing a notebook on any page into Colab. And the collaboration and sharing model is the same one you're familiar with if you've used Google Drive, Docs and Sheets and so on. I put a little asterisk next to collaboration because you can't actually collaborate in real time on the notebook in the same way you can in a Google Doc, where you'll actually see somebody typing the characters. But multiple people can be in the same notebook and you can share access to it and refresh it to see what's happening. So it's not quite as fine-grained collaboration as I might like, but it still gives the ability for teams to work together on common notebooks hosted in the cloud. You can load and save directly from and to Google Drive and GitHub, which is really convenient. And you have access to GPUs and TPUs, which is nice for if you're trying to do machine learning with larger models. There's also a service called Colab Pro, which is a paid service, which gives you a little bit of upgraded, sort of more predictable environment. You get priority access to hardware accelerators, longer lived backends, a bit more resources in the Jupyter kernel. And at the moment, it's limited to the US, but it's being rolled out more widely. The cost of Colab is quite reasonable. It's free, my favorite price for the basic service, and it's $9.99 a month for this Colab Pro upgraded service. And there's a link there if you want to find out more about Colab Pro. What are the limitations? Well, it's because it's a mass service. It's basically, the resources are as fair as we can make them, but it's a pooled server kind of product. So, you're contending with the rest of the community of people using this service for access to resources, which means it's less predictable and more dynamic. Now, it will be usage-based, and so if you consume a lot of resources, you will find that your response time degrades gradually over time. So there's less guarantee, but for most kind of casual use, it's quite adequate. It's Python only, in fact, Python 3 only. And so a couple of recommended things to do when you're using Colab is close the tabs when you're done working with a notebook, just to consume the least amount of resources. And if you're not using a GPU actively, unconfigure it. And that way you'll get higher priority access to, or you'll likely see better availability and response time on when you actually need a GPU or a TPU. And finally, Colab is great for casual use, weekend explorations. And it's super, I think, for education and training because it's got such nice low friction. The next service I want to talk about is Kaggle. Kaggle is a kind of online community for people who are interested in data science. And it's gotten quite famous for its competitions, but it has a lot of features beyond that that go in the way of integrating data sets into the site, and they have their own kind of integrated Jupyter Notebook implementation. But the key value here is you're kind of working in a very focused domain of data science, excuse me, and machine learning. And so you're benefiting from a whole community of practitioners, including some very advanced ones. A couple of examples, there's a really nice traveling Santa problem, which is a take on the traveling salesperson problem, which is a famous NP complete or NP hard theoretical problem in computer science. And the notebook walks you through actually attempting to solve that problem interactively. I also went and looked for the top rated. So because it's a kind of a community environment, you can do something that you can't do with Colab, which is search all of the notebooks. And I'm guessing in a way you can search the Colab notebooks through Drive, but it's just a little bit more obvious in Kaggle. And you can find the ones that are most referenced and most cloned, like GitHub repos, and most highly rated. And so I found the highest rated one, and it's this comprehensive data exploration notebook. Quite amazing, lots of examples. It's almost like a book, really is kind of like an online book. So I encourage you to take a look at that if you're interested in learning more, either about that subject, data science, data exploration, or if you just want to see the kinds of things you can do with a Kaggle notebook. Some of the features, it's integrated with Kaggle, so it has some nice capabilities in terms of working with competitions and data sets. Also well integrated with Google Cloud. For example, you can access TPUs and other Google Cloud services from within a Kaggle notebook. As I mentioned earlier, searchable, more rated and searchable content. They have some nice online courses, and check out this link, Intro to SQL Using BigQuery, which is essentially a Kaggle notebook that is structured like an interactive course, self-study course. And finally, there's a feature called Kaggle in Class, which is great for students if you want to run sort of private competitions in the classroom. The cost is free. That's an easy one. The limitations here are that there are fixed resources, similar to Colab, although the actual specification is a little bit more crisp here, whereas with Colab, it sort of varies over time as we improve the hardware. And these will undoubtedly vary as well, but they document exactly what they are at the moment. So I won't go through this list, but it's the memory, the CPU, GPU allocation, etc. And your sessions will time out if you're idle after 60 minutes. This is great for really if you're interested in machine learning, AI, data science, any of those areas. If you like these competitions, not only to participate in them, but just to follow them and find out what tactics and strategies are working best for most people. It's really instructive. Hackathons it's great for. We've got a program in Google Developer Relations where we go into companies and run private competitions, and it's just a super effective way to learn and to build some team connections as well. And the sort of underlying all these items is education and training. The last type of notebook I wanted to call your attention to is AI platform notebooks. So these are really the highest performance and the most predictable performance option of the three. And these are really focused on production use. And there's a great document called the Notebook Manifesto, which kind of gives you the background behind what went into the design of AI platform notebooks and why they are the way they are. And if I had to tell you in just a few words, it's the idea is kind of bringing all of the rigor and the formalism and the predictability of modern software engineering practices to this notebook environment. So that's the motivation. And I think they've done a good job in that direction. And I think there's more to do, but they've really made these notebooks ready for production use by businesses. So the two examples I have, one is a demo that I can show you of one I've created, and one is a code lab by my colleague, Sarah Robinson, which walks you through doing a TensorFlow model, training and using a TensorFlow model and using the what if tool on it in the environment of one of these cloud AI notebooks. So recommend trying that as well. Some of the features, as with the others, it's managed by Google, so you don't have to worry about any kind of administration other than creating the notebooks. It's one-click deploy kind of user interface. It's backed by the deep learning virtual machine, which if you haven't seen it, it's a very powerful Google Compute Engine VM virtual machine with lots of hardware resources that are well suited for machine learning, but also a lot of the software services you would want. So TensorFlow, PyTorch, all the typical Python libraries, R, SciPy, NumPy, all the good stuff you would typically want if you were doing serious machine learning. You can fine tune the actual resources when you create the notebook environment. And so unlike with Colab or with Kaggle notebooks, you can actually specify what kind of operating system, what kind of hardware, CPU, memory, disk configuration you want. So you have a lot of control over it. In fact, you can even bring your own Docker container to automatically integrate into the notebook environment. I don't think I say it here, I probably should, is it's based on Jupyter Lab. And so the kind of sort of unit of interaction is unlike the other two products where the basic unit of interaction is a notebook. The unit of interaction here is kind of a meta interface. It's this Jupyter Lab interface, which is an open source. You can think of it as an IDE for Jupyter notebooks. So when you go in, instead of just jumping into a notebook, you go into an environment where you can open, close notebooks, manage them, share notebooks, etc. So it's more of a higher level and a more comprehensive kind of user experience than the other two tools. As I've hit on already, it's production oriented, meaning it has nice capabilities with continuous integration, continuous deployment, logging. It's very well integrated with GitHub in a way I haven't seen. I already mentioned that on the previous point, but in a way I haven't seen with a lot of these notebooks. So right from within the notebook, you can do commits and pull requests and check out repos and all that kind of stuff. So it's quite a nice capability and I think quite unique. You have access to all the other the hardware accelerators you would want, a bunch of different GPUs, and the Google TPUs are available as well. There's a notebook API, which is kind of cool. I haven't played around with this yet, but it basically gives you the ability to programmatically orchestrate the operation of these notebooks. So you can write code that creates notebooks, edits notebooks. You can schedule things to happen in notebooks. And I think we've only just started to scratch the surface of the power there, but that's pretty cool. And of course, it's more predictable. You have unlimited server lifetime, and the performance is not throttled. You don't have to worry about degrading performance over time if you use too many resources. Now, the reason we can guarantee such good performance is this is the one of the three that you actually do have to pay for, apart from Colab Pro. And the cost model is such that there's no direct cost for notebooks per se. So you can use the notebook all you want to do, Python coding or whatnot. And no matter how hard you use it, the notebook itself won't accrue charges, but you will accrue charges for the underlying Google Cloud resources that you use. So the compute that you configure, and by default, you get an N1 standard for a particular type of virtual machine. And the storage that you configure, you do pay for those. As well, depending on what you do in the notebook, if you reach out and do interactions with other cloud services like BigQuery, cloud storage, AI platform, etc., you will incur charges from those services. And if you're interested in finding out more, there's a really nice resource called the pricing calculator. And I'll just show you what that looks like really quickly. You can choose a cloud service. So here's cloud storage, and you can specify how much storage you're interested in having available and what class, what service class of storage, what location where you want to store it. Yeah, I won't go into too deep here, but just about any product and configuration you can think of. Here's AI platform. You can key in here and it will give you an estimate of how much that will cost you. So that's one good way if you're a little concerned about the costs associated with the AI platform notebooks. That's one good way to get a rough estimate of how much you can expect to use up depending on what you do with your notebooks. There really aren't many limitations. There's a specific set of supported hardware and kernels and operating system environments, but it's actually quite an extensive list. So I probably shouldn't even call that a limitation. It's more of a feature. And the other limitation is not free. So as I already said, you need to manage your usage to ensure your costs are meeting your expectations. This notebook is great for commercial, industrial, professional use. The source control factor is great for kind of an engineering environment where you have teams collaborating on notebooks and you want to have them as well managed and as predictable, evolving as predictably as source code. This is really bringing us a big step towards notebooks as source code, in my opinion. If you want predictable performance and if you want to customize or fine-tune the environment behind the notebook, this is a great option for you. So I'll summarize some guidance. And I think this probably has already come out. I'm sure it has, but just to kind of tie it all together, if you're a casual user focused on teaching and learning or kind of ad hoc experimentation, I recommend Colab. It's the easiest one to get started with. If you're really interested in ML and AI or data science or going beyond kind of into more advanced teaching where you want to really get down to diving deeply into some of these topics, then I recommend Kaggle because it's kind of where all the advanced practitioners are now, and you'll learn a lot just by looking at the competitions and what the winners are doing in these competitions and so on. And then finally, if you're looking to use the notebook in an industrial sort of professional, there's a whole ecosystem around this this tooling, and I've listed a bunch of them here for you. I won't go through this list, but I have a little summary of each one, and it's really nice that these. I guess one thing I should say is all of the 3 notebooks I've told you about are built on this open source Jupyter product, and what that means is, for the most part, I'm not going to say 100%, but for the bulk of user experiences and authoring experiences, you will find that these open source kind of add-on tools and things work well in all 3 of these environments. And the other thing is, if you have a notebook that you've authored anywhere with this standard Jupyter specification, so that the file extension is IPYNB, which kind of goes back to its original name, but at any rate, if you author a Jupyter notebook in any one of these environments or in a third-party environment, there's a high likelihood that you'll be able to interactively move it right into this environment or move it around from one of the 3 I showed you to any other one, which is really nice, right? It's getting us away from these proprietary silos, and it's a much more open kind of environment and sharing kind of environment. There's a bunch of other, I'm really interested in this area in general about helping people learn and teach using technology. And so I've created a GitHub repo with a list of teaching tools that are not necessarily related to Jupyter, but some of them are. Feel free to take a look at that. I just actually set it up. It's not the best looking repo ever, but it's got all the tools I was able to think of and gather recently. Send me a pull request if you know some that I'm missing there. Finally, I wanted to close with this slide, which I use in most of my talks. This is Tim Berners-Lee, who famously designed the World Wide Web many years ago. And one of his slogans was, "This is for everyone." He really designed it to help, to make it available for everyone who wanted to use this new technology. And I feel like notebooks are another step in that, a smaller step, of course. I'm not trying to equate it to the web, but it's another step in the direction of making it easier for people who haven't come up through the tech area or haven't, gotten their degree in computer science to get access to some of the latest technology and tools and to be able to learn about it in a friendlier way. And I think I managed to just fill my time without getting to any of my demos. I have 30 seconds left. I'll do a 30-second demo.
Yeah, good timing though, good timing.
Okay,
yeah, so I'll leave you to go to the demo and yeah.
One of the fun ones I'll show you, I'm using up the 30 seconds with my looking for the, okay, yeah, it was the Colab one. Okay, so the digit classification one, actually that was a waste of time because I had it open. Reconnect. Now I don't know if this is going to work because I'm reconnecting to the server, and that's one of the issues with these notebooks is you have to make sure the server's still in the state you think it is, or you have to rerun your cells. Okay, so this is working. What I've done in this notebook is I've trained a MNIST recognition, that's a handwritten digit recognition data set using Keras and TensorBoard for looking at how the training goes. And the cool thing is we do it in 3 steps. Good is the simplest functional network, and it's this really short, small chunk of code. Better is where we add more capabilities, and best is a more robust kind of professional level solution, a lot more code, although still pretty small because Keras is so expressive. And you can see I trained this just before this talk. And then I'm using some cute tricks that Colab provides for running web widgets right inside the notebook. So what I've done now is that the model that I've trained just in the cells above, I can now test interactively by drawing in this cell. And so you see the model thinks it's figured out it's a 2. I can sort of trick it by making it look like a 7. You see the model isn't sure if it's a 7 or a 5. Now it's sure it's a 7, but now I'm going to turn it into a 3. And you can sort of see it interactively. It's guessing as I'm drawing, and you can see that's kind of fun because it's using the model we actually trained right in this notebook. And I think that's probably about all the time I have for the talk, but I invite you to try any of these other demos yourself. They should all be, I think most of them should be available. One is the AI platform notebook because it's tied to a particular cloud account and payable resources. You may not be able to run that demo yourself, but yeah, I hope you enjoyed this. Hope it was helpful to you. And this is my Twitter at Mark A. Cohen and my blog mco.dev. Feel free to reach out to me if there's anything I can help you with. Thanks.
Awesome, Mark. Thank you so much. It was very helpful for me as well. As a machine learning engineer and love notebooks. Have been my daily driver since ever, and amazing.
Cool.
So, well, thank you again, Mark. Amazing presentation. You have great fans in the comments. You can check them later. But yeah.
Cool. Thanks for having me.
Thank you. Have a nice day. Okay. Bye-bye. Well, guys, so now we're gonna go a little bit on a coffee break, and we'll be back at 12:15. So enjoy your coffee, and see you back at 12:15.
Well, hello and welcome back after your tea break. I hope everybody's well hydrated and you've all taken your required bathroom breaks. Hey, Erica, we've got a great after session. We have Luiz Gustavo Martins joining us. Hello, sir. It is great to have you on board. Luiz goes by Gus. It's great to meet you, Gus. You're a pretty interesting guy. I mean, moving above and beyond your machine learning and TensorFlow contributions, you were a capoeira teacher. That's pretty cool.
Yeah, it's a hobby of mine. I've been doing this for more than 20 years. I don't even remember yet.
Really?
Yeah.
My lord. For anybody that doesn't know what capoeira is, that's the Brazilian dance martial arts. Is that right? I'd ask you to give us a demonstration, but maybe it's not the right time or place.
Yeah, not now, not right now.
Not right now. Okay, that's fair enough. So for any of you who are watching since the very start here today, you might recognize Gus as he was a part of the hero video released by Google that we played at the very start of DevFest 2020. He was doing some of his machine learning magic, as he refers to it as. And something that I think has been catching on. You do a lot of drawing from YouTube with your daughter. My sons do the same thing. They pick a tutorial on YouTube and try and follow it through. It seems technology is entering everywhere into our lives, isn't it?
Yeah, it's great. And it's like I always thought I couldn't draw properly myself. But when you start to follow the videos, you learn so much, and then you can do that with your daughter, and then you have this thing, right, that you do together. That's amazing. Yeah, technology, man, it's great.
It is, even for something that's more physical and manual, like drawing. Yes. By its very being is something we do in the real world and not in cyberspace, but it's even approaching it there. I think it's fantastic, and the way it's helping our lives and even creating bonds between you and your daughter, me and my sons.
Yes.
It's fantastic. So machine learning and TensorFlow. I know you are your talk is at TensorFlow Hub, making machine learning easier, and you work for Google.
Yes, I am on the TensorFlow developer advocacy team. So my main goal is to make machine learning easier for all the developers. I hope I can do a little bit of that today, and I keep doing that every day. That's something I really love doing, to help everyone learn everything I know. So that's my main drive these days, to help you all, because it's not an easy field. There's a lot of things to learn. So my goal is always to, I learn something new. Let me try to share this with more people so that all of us can evolve together.
What's that? They say about a rising tide raises all ships. That's
exactly. Oh, that's a good one. Yeah,
it is. No. Well, listen, Gus, we don't want to take away from the time you have allotted to share your wisdom with us. Erica, unless there's anything you'd like to ask Gus before we get started.
No, I'm kind of a blank canvas when it comes to the machine learning. So if you can make it even easier than it already is, I'm psyched.
So let's hope I can do that.
Fantastic, Gus. If you want to share your screen, and we will just go exit stage left. We will be watching from the backstage, and we'll be there should you need us.
Okay, if you need anything, just leave a comment here. I can read the comment with the side of my head. So if something goes wrong, just let me know.
Of course not. Thank you very much, Gus. Talk to you soon.
Hi, everyone. Good morning, good afternoon, depends if you had lunch or not, I guess. My name is Gus. I work on the TensorFlow team as a developer advocate. And today I'd like to talk a little bit about TensorFlow Hub and how to make models easier to use for everyone. And let's go. So if you've been doing machine learning for a while or just started, there is a challenge that you always face. And let me start from my story. You just see a paper, this is a nice content. Let me you read it, and then you learn some things, and then, let me try this. And that comes the next step. There might be on the paper a link to a code repository somewhere, and then you just follow that link, if the link exists there, or if you have maybe search on Google for a reference for the paper, and then you find the code repository, and then what do? You have to learn how to use the model. And this is a problem because everyone documents their model in a different way because they think it's the best way. and so everyone documents differently. So when you get to the code repository, you don't know how to run the model to start with. Sometimes there's a README, sometimes there's a very good README with all the instructions. Sometimes you have to go into the Python code yourself and find where the model is, or maybe you need to download from somewhere else. And then you have to learn how to use it. What are the parameters? Or maybe if this model is fair, was the data used there taking fairness into account? Or maybe, is this the latest version? Maybe it's not. Maybe there's an update somewhere else. So there's a lot of questions that come that we, it's hard to solve, right? Because everyone will document completely different. And if you want just to try the model to see the results really fast, and you don't have like 2-3 days to dig into other people's code and documentation, everything, that's a bummer. And if you're a developer and you're trying to solve a problem, maybe you don't have like 2-3 days to keep researching, right? You want to see something and say, and from there make your decisions. That's why we created TensorFlow Hub. TensorFlow Hub is a machine learning model repository where you can download models to solve a lot of tasks. These models are already readily available. You can try some of them directly from TensorFlow Hub. You have a full documentation, have sample code, you have descriptions, you have the pros and cons of most of the models, you have multiple versions. So I'd like to take you on a tour to see all these features, and we are going to look into some examples how to use it and maybe learn something new today. So for example, if we want to find what's in this image, people would use a image classification model. So you get this is a Indian elephant. So image classification is a very important class of problems. Or maybe you want to go deeper, right? You want to find not what's in the image, but where something is in the image. So we do object detection. And this is a more advanced, is the next step from image classification, I guess. Or maybe you want to go even deeper. You want to cut exactly what is in the image, right? So you want to do image segmentation, which is the next step from object detection. Or maybe you don't want to do that. You want to create images from nothing, right? So as you want to create new images to use in your somewhere in a presentation, somewhere you want to create, and you don't want to worry about, I don't know if there's any copyrights related to the image. So you want to generate the image. All these images here are computer generated, right? If you look very closely, you can see that there are some details there that are not, you would say, oh, there's something off here. It's because those images were created from machines, created by machines from zero, right? Or maybe you want to do something even cooler. You want to apply style transfer, which is applying a style from an image to another. And we're talking about this a little bit more soon. So all these models, all these tasks, you can find models for that on TensorFlow Hub for all these tasks. And then you're going to think, okay, is it only for image models? No, it's not. We have a lot of models for text, so we can do text classification. We have all text embeddings in a lot of languages, not only English, of course. We have you can do question answer, you can do a lot of other things, but it's not only image and text. We also have models for video and audio, which is something that you don't see every day. And we're going to see some examples in a little bit, but you can do pitch detection, you can do sound classification, you can do activity recognition. There's a lot of models already available for you. And the cool thing is, those models can be deployed in multiple platforms. So they are not only for your server. You can use some of them, for example, on your TensorFlow Extended pipeline. So if you don't know what TensorFlow Extended is, TensorFlow tooling to create professional pipelines that goes from data prep, model training, model tuning, until you do serving. So it does all the process for you, help you in all these steps, so you can deploy your model to do transfer learning, for example, to improve the model on your pipeline. Or you can deploy your model to the web, right? Using TensorFlow.js. We have models available, readily available for TensorFlow.js. And of course, if you want to deploy a model, as you've seen on the hero video, you can deploy models to your TensorFlow, to mobile, to the phone, using TensorFlow Lite. We also have models for that, and Coral, which are the embedded devices. We have models also specifically for that platform. And we have more than 1,000 of models. There's a lot to look into. So if you want to, I don't know, spend searching for new cool things, that's a good place to start. And another good thing is the models, some of them, not all of them, sorry for that, but some of them, they right on the models page, you can try it. You don't need to download anything. You open the models page, the first thing you're going to see after, of course, the model description is a sample that you can try, like the birds, for example. You can drag an image of a bird, and then it will tell which bird it is, or which food it is, or you can sing to the microphone and see how good is your pitch. I tried only once because I hate my voice, so I tried. I saw, okay, now it works, great. Let's go on with it. But it's so the good thing is you can try the models before having to deploy any code at all. You just take a look and say, oh, so this is the capabilities I have. So great, that's what we can do. And we have one example of a specific model. And one important thing I want you to pay attention is that there is an Open Collab notebook there. So what this button does is, the good thing is that you can click on this button. It will open directly a collab with a sample code for this model specifically. This is specifically the mobile net v2. So you have already code that works and that helps you understand how the model works. You don't need to write anything. You just follow along, and then you learn and say, okay, nice. And then you can adapt the collab for whatever need you have. So this is an amazing start, because first of all, here, as you can see, you don't need to go figure out how things work. There's an example for you. If you need to read more, there's the documentation for you. And if you need, for example, in another format, there is already, in this case specifically, TensorFlow JS versions of the model for you to try right there, or you can download the model. So all the information you need is right there. Let's see some examples, and then try to have a better understanding of how TensorFlow Hub works. Let's start with style transfer. This is a very dear to me. I really like this kind of example. So what is style transfer? You have a content image, here's the dog, and you have a style image, here's a painting. And what you want to do is you want to make the dog image, the content image, look like it was painted in the same style as the painting image here, right? So this is a cool machine learning use. And let's see how we would do that with TensorFlow Hub. First of all, you need to find the module in TensorFlow Hub. You go and search, and you find image style transfer. We have, this is the one of the main ones, arbitrary image stylization. And here we already learned something here. First, if you copy that link, I'm not going to, you don't need to, you just search for style transfer, you get to that link on TensorFlow Hub. If you copy that link and put directly on your browser, you get access to the documentation of the model already. So this hub handle is the documentation. It's a way also to download the model. And how do I download the model? So we'd like to help you with this, all this. So first of all, we import TensorFlow Hub, of course. And then if you look into the third line, hub.load, that's all you need to download the model and have it ready, available for inference. That's it. You don't need to do anything else. Next thing you need to do is use the model. So here we are giving the model two images, right? Content image and style image, and it will return for us the stylized image. And then you show it. That's it. Of course, I've hidden from you some details on how I loaded the content image, the style image, just to make the example shorter, but that's like boilerplate code, right? The important part is exactly this. And we have this result here. And this is a very cool example. There's a link for the tutorials if you want to take a look and play around with that. It's very simple. You can just, if you write this code, or if you go into the Colab that's available in style transfer, you'll see something very similar, the full example there. Let's see something else, right? Let's do some image extrapolation. Image extrapolation is I'll give you an image, and then I'll cut part of this image, and then the model will generate back this image, this part of image. And then you can use that to make your image larger, for example. You can extrapolate your image. And we also have a model for that. It's called Boundless. And it's, as you can see, the way of using the model is very, very similar. Import TensorFlow Hub dependency, use the handle that you found on TensorFlow Hub. Same thing, you can copy this and see the documentation. Load. Oh, there's a typo there. So sorry for that. The hub module there should be module. Sorry for that. I'll fix it later. You give an image, and then it will give you the result, and you have the three results from that you can see in the image, original, masked, and generated. It will come back as result, and then you can take a look. There's a tutorial for Boundless also if you want to play around. This is more to learn how to use hub, right? This model is, you use this model, you don't fine-tune this model specifically. So this is another one, and since we're just talk about fine-tune, let's take a look on how we can do some fine-tuning. So for text classification, usually everyone does fine-tuning, right? You want to do I guess the first thing you try when you do text classification is sentiment analysis. And sentiment analysis, you have a piece of text and you want to know if what's written there is something positive or negative, right? This is a very basic text classification use, right? Let's do it by hand. Here we are going to apply a different technique than the load that we've been using, right? We are going to create a model. We are going to use hub as part of our model. So we are going, of course, import TensorFlow and TensorFlow hub. Next thing is we get this model handle. This handle specifically is a embedding, English embedding with 128 dimensions, right? So, and the 2 in the end is because this is a version 2. So here you can see that we have version control for the model. So you know if you're using the latest one, you can just go and see which versions are available. If your process required a specific version and you don't want to update, you can keep using the specific version. There's no problem. Right, and here we are going to use the new thing is hub.keras layer. What this does, it creates a layer, a keras layer, of course, that's the embedding for our model. And then we can use this as part of our model. And that's what we're going to do now. We are going to create a sequential model. First layer is going to be our embedding. So you're going to receive text. As you can see, the input is a string, right? And we mark that as trainable true. So the weights are going to be fine-tuned a little bit. And to have the embedding, then you just add 2 dense layers, just to make it as simple as possible. We are, of course, going to define our optimizers Adam, super basic, loss, binary, cross-entropy, because we have 2 classes, right? It's positive or negative, and the metrics accuracy, and we train. That's it. Boom. That's all you need to do sentiment analysis. Of course, you will get some good results here, maybe something close to 80% or maybe a little bit more. And that's, given all the work you have to put here, that's kind of easy, right? For the full example, you can follow the tutorials on text classification. Of course, as you can see here, the train data, I didn't put anything about train data here because this thing, so the fun thing about text classification is that this is the machine learning part, right? This is where you create a model, where you train things. If you look into how much code goes into prepping the data, it's way more than that. So what the goal here is to show that, look, the machine learning part is simple, not easy, it's simple. You can do that with very few lines of code. We are trying to help you as much as possible. Let's see one last example. Let's not last, the one before the last. Let's do some sound classification. Sound classification is you give a wave file, and it's going to be converted to an array of integers or floats, and then it's going to be classified at which sounds are on this wave file, right? So we have a new model that was released like maybe 1-2 weeks ago called YumNet. YumNet is a sound classification model that classifies in 521 classes, and this is how easy it is to use. You load the model handle, same thing. Oh, look, you can see the 4 lines are always the same. Import dependencies, get the model handle, load it, and then you load your sound file from your path. You can upload to Colab. You can have locally download from the internet, doesn't matter. You have to convert to the proper format. In this case, it's a mono file on 16,000 frequency hertz and 16-bit bit width. So that's very vanilla configuration, right? There's no stereo, no 32-bit audio, 16. And then you convert, do all the things, and then you just apply the model. And you have 3 results, which are scores, embeddings, and the spectrogram. The spectrogram is the second graph you can see there, the green one. So you can see how the wave behaves. You can see the first one is your sound data directly plotted So this is what happens. So you can see there's some kind of silence, and then something happens, something silence, something happens. And then you have your scores plotted for you. As you can see, there's a score for each kind of frame of sound. So this model is applied for every half second. So you can see for every half second what was classified. So it's animal, domestic, pet, cat. So it's probably a cat, right? You can see all the classes it classified for you. And again, sound classification made easy for you. Let's see the last one. And the last one is transfer learning. So if you saw the hero video was about creating a model that does bean disease classification. And it was very fast. There's a blog post. There's a collab for that if you want to play with it. And sorry, everything's going fine, right? No, it's going fine. I'm just looking to the comments to see if presentation is going fine. And so the good thing is we did this on the hero video, and I'm going to show briefly what I did there. First of all, we need the data. And the data, we have this data already on TensorFlow datasets. The beans dataset is available to you. You just download it. You download and you have access to the already split it into train data, validation, and tests with labeled. Everything is ready for you. You don't need to do much here. Next step is we need a base model to do transfer learning. Lucky for us, we have a cassava disease feature vector. What's a feature vector? We have two kinds of cassava disease models. We have the classification version and we have the feature vector. The classification version, you give an image and it tells you if the cassava leaf is good or bad, or which disease it has. So it does all the way. The feature vector doesn't do everything. It just receives an image and extract all the features from that image, and then you can use this to create a model for you, for your own use case. So you can apply, use this knowledge already embedded in the model to create your own model. And that's what we're going to do. We are going to use a sequential model. We are going, again, Keras layer with our feature vector. And then we are going to just put a dense layer, a dropout, and another dense layer. For the beans specifically, there's 3 diseases it classifies, or it's 2 diseases and 1 okay. I don't remember. I guess it's 3 diseases. And the thing is, you just do that, compile, fit, you have the model. That's all you need. You do the fine tuning here. It takes maybe 5 minutes, 10 minutes to do the fit, to train the model, retrain the model, and you get a result close to 93% accuracy. So 90% accuracy for this work, it's great, right? You didn't spend like days doing research, and now, given you have this 93%, you can try to improve the model yourself. You can try to play around with parameters, with layers, with the data set, but you already have a benchmark for yourself, right? If you can do better than 90%, 93%, that's great. Or if you can't, you just use this model that's super simple. And that's it. Transfer learning, use TensorFlow Hub. If you want more examples, you can follow the TensorFlow.org/hub/tutorials. There's a lot of other examples there with other models, and you can learn a bunch of new cool things there. Let's see how TensorFlow Hub works behind the library, right? What's going on there? What's happening? Here, let's use part of our example there. So here I'm going to import TensorFlow Hub, of course, load the embeddings, and just play with the embeddings, right? Doesn't matter what I'm doing there. The important thing is I'm downloading a model from Hub, and I'm using that. So what happens behind the curve here? So when we download the model, when we do load, the model is downloaded from our storage, right? From the model assets storage. And this, of course, this is GCP, right? Is on Google Cloud Platform Storage System. And this is important, and I'll tell you why in a little bit. So this, you download your model from there, and then it's stored locally for you on a temp directory. Of course, if you want to change that, you might want to change that, and I'll tell you why in a little bit too. So you can change where the model will be saved. And next time you load the model, it's going to use the local version directly. It's not going to keep downloading this every time, because it takes, some models are more than 500 megabytes, right? So you don't want to keep downloading big assets all the time. Or if you have that on your pipeline, for example, TFX pipeline, you don't want to, and you retrain your model multiple times a day, you don't want to have this, to pay this tax of downloading all the time, right? And why would you want to change that? So for example, if you want to download a model and convert to TensorFlow Lite using specific configurations, you need to know where the model is, right? So this is where you can define a place, and then you know, oh, the model is here because I configured to be there, and then boom, you have the model where it is, and you can play with that. Or if you want to, don't know, inspect the model or do other things directly on the files, it's all there available to you. You can play with that. Here, if you just go to the directory where usually the models are saved, you can see we have the assets, we have the saved model, of course, the variables, and this allow you to see, for example, a vocabulary file that's there. You can see some other informations that the model publisher left for you there. Let's see what's new in terms of TensorFlow Hub. There's a lot of new things, and there are updates based on an almost weekly basis. Of course, we are always improving search to make it easier for you to find anything you need. And we added some ways of filtering. So if you want a model that's for TensorFlow JS because you're working on a web project, or if it's a TensorFlow Lite because you're working on a mobile project, or if you want something that's fine-tunable, you want to use that model as part of your bigger model, you can define this in the search, and you have better search results. Of course, you can define a problem domain. So you can, I want to find models to do object detection. You can select object detection, or you want to do models for, you want text embeddings, you want sound embeddings, you want whatever. You just go there and filter by problem domain, and then you can see all the models available for you. And we've improved multiple things. TensorFlow Lite metadata in TensorFlow Lite is a way to embed in the model information on how to use that model. So there's a description, version, whoever created the model, what are the inputs, what are the outputs, all this information is embedded in the model, right? This helps mobile developers to understand better what's going on. So what we did to TensorFlow Hub is, first of all, you can, for every TensorFlow Lite model that has metadata, which is are most of them, you can see the metadata already on the browser. You don't need to download and see what's in there. You can just look into there. And aside from that, we have a separate version. We say that, look, this model have metadata, so it's even easier for you to know if the metadata is there or not. And so this makes deploying models much easier. And we have a lot of TensorFlow JS models always being published. We have one that was published recently, which measures the distance you are from a camera by the size of your eye, which is great. So you can, it's the iris model, right? You can go take a look, play around with that. And we are always improving our TensorFlow JS integration here. And one thing that you've seen today already is we have the ML Kit Android Studio support, where you can just in your Android Studio, you download the TensorFlow Lite model from Hub, you go to Android Studio, and they'll import TensorFlow Lite model, choose this file, and it will create a class for you that will already populate all the methods and show you how to use the class. So this is what we did for the Hero video, right? That's how we built the sample app. This makes using TensorFlow Lite models way easier, way easier. So if you've been developing using TensorFlow Lite, I don't know, for a year, and you remember how it was in the beginning 1 year ago, you know that this makes life way easier. And this is because we have the metadata, we have the models already available on Hub, we have the integration with Android Studio, so everything to help you on your journey. One important thing that you might think is, okay, all these models, they are there, I can use, but they are all Google models, right? Of course, most of the models are from Google and TensorFlow, DeepMind, because we created the tool and we want to share, but it's open to everyone. And we have a lot of partners that already publish models. And the important thing is that it's not, we don't want only big companies to publish their models. We want everyone. So we have models from Kaggle competitors that they won some competitions. We invited them to publish those models. We have models from GDE, Google Developer Experts, that there are a bunch of them giving talks today. So they also publish their models, and we want the community to publish, right? So we want everyone to have access to this, and to make it easier for you to share. And if you want to share, here's a link. And that's it. Please go to TensorFlowHub.dev, have fun, and thank you very much.
Thank you so much, Gus. That was very enlightening, especially the bit at the end where we were all about community here in the GDGs. Erica, I know, is excited to go and have a look at TensorFlow Hub. I know some of our other speakers today use TensorFlow Hub, so we'll probably hear a lot more about it throughout the day. Thank you so much for sharing it, and thank you for making our lives that little bit easier. Are you happy to be contacted? Yeah, you have your slide up on there. Of course, you're happy to be contacted.
Yes. So if you have any questions, just ping me on Twitter. I'm always there. I try to answer. I hope it was helpful and people learned something. And yeah.
Thank you very much, Gus. You have a very good day.
For you too. Enjoy. See you later.
Thank you. Well, speaking of Google development experts, we actually have the youngest one from Pakistan up next. So we have Emad Ehsan is going to be doing his discussion on building custom deep learning models to recognize British foods with Cloud AutoML and no code. So he's currently the chief tech officer at Traverse, which I just started checking out. It's this really cool travel journal app. It's awesome. It's just been awesome. But more interestingly, you can ride a unicycle. I struggle on 2 wheels. Like, that's just wildly interesting.
Emad, can you hear us? Emad, are you with us? Emad was having some technical issues with his webcam driver earlier on today. So Emad, can you hear us? We can't hear you. Hello? It says you should be available, but we don't hear you. Do you have a set of headphones you could possibly plug in? We can't hear you, Emad. So technical gremlins notwithstanding, yeah, Emad is a very interesting dude. Youngest GDE from Pakistan, and there is a lot of GDEs from that neck of the woods. Really smart guys. Oh, we have Emad jumping back in. Let's see. Hello, Emad. I think maybe your audio driver maybe gone as well. Buddy, do you want to use your phone? The youngest GD from Pakistan. We have this. Hi, Emad. Yes, we're getting some messages here from Emad in the chat. Emad can hear us, but we can't hear you. There seems to be a problem coming our direction. Have you selected the input down on cam and mic, maybe? You can't have a proper live stream without some technical gremlins, isn't that right, Erica?
Keeps it interesting.
It does keep it interesting. I do have headphones on. Okay. Emad, device not connected. Can you reconnect again, please, Emad, and see if we can get this going? Here we go. Add to stream. Hello, Emad. Do you want to try the cam and mic settings just at the bottom of the screen? Maybe select a different option.
Although I do think it's interesting. So Nadira posted hello from Uzbekistan, which is one of the most interesting places that Iman said that he's ever spoken at a tech conference.
Ah, that's a nice coincidence.
Right?
Maybe they've run into each other at that conference. Wouldn't that be awesome?
That would be quite funny. She was like, I remember that guy.
I know who that guy is. What was it? One of my friends was talking to me there most recently about the universe conspiring. You know, and isn't it just? Here we go. Hello, Emad.
Hello. Can you hear me?
We can hear you.
Okay, I have connected from a third device now.
Fantastic.
They are
Isn't
always
technology
unexpected.
brilliant? That's
I
the life of
appreciate
an
the
engineer, guys.
dedication.
Absolutely. Otherwise, it would be Erica and I show for the next half an hour. We're so glad you jumped in to save us.
Okay.
And our viewers.
Thank you for waiting for me. So let me try to share my screen. I hope.
Yep.
That will go well.
So do I. Here we go. And we have Emad's screen.
And can you now hear the see the slides?
Yes, sir. Emad,
okay.
It's fantastic.
Yes.
I know you're anxious to get started because with the gremlins and
sure.
there. I just wanted to make a note that when I read your story and did a bit of research when I knew you were coming on, I know you grew up in a very remote village in Pakistan, and that your parents put in a lot of work and a lot of dedication, as well as you putting in the dedication to get where you are today. And I just think it's a fantastic story of your dedication, your willingness to learn, and now share what you've learned. Is there anything you'd like to say if your parents are watching?
Yeah, it truly has been a really great and fulfilling journey to get to where I have gotten, and it would not have been possible without the support of my parents and their sacrifices. So I hope they'll be watching sometime when I share this video with them. So Ammi Baba, thank you so much. And
Well, Mr. and Mrs. Ehsan, you should be very proud. With that said, Emad, we will drop off into the backstage and let you continue with your talk. We're very excited to hear what you have to say. And also, he's a GDE, youngest ever youngest in Pakistan. Great notoriety there, sir. Thank you very much. We'll talk to you at the minutes.
Perfect. So today I'll be talking about creating a food recognizing model using AutoML. And I am Emad Ehsan. I am a Google developer expert from Pakistan. And let's jump right into it. What do you see when you see a photo of a bird? So we humans are a lot dependent upon our visual clues. And when we see a photo of a bird, we can recognize that it is a bird and it belongs to a certain species. But if you see another photo of the same bird, same size, you cannot confidently say that whether it's the same bird or it is photo of another bird of the same species. Take a look at this photo, for example. Let's say all these puppies belong to you and you have given some names to each of these cute puppies. How confident are you that when you say one of them, will you be able to identify which one of them is it? So for me, it's actually pretty hard. And when it comes to cuisine and food of areas of different countries, different places, the problem becomes a bit more complex, because here we have, for example, in this photo, on the left we have keema, which is a food very popular in subcontinent, and on the right we have Scottish haggis. I hope I'm pronouncing that right. And to me, both of these dishes look the same, except the coloring and the colors of the photo, some color condition that someone manipulated while taking those photos. But essentially, when you are traveling from places to places, it's a real struggle to actually differentiate different dishes just by looking at them. So you actually have to learn how they taste. You usually interact with the locals and you see how it is made. So all those stories and all those experiences help you understand what makes this dish unique. So let's say you want to create a photo app for travelers where they could search by photos. They would upload the photo of a dish, and your machine learning model would be able to identify whether this photo belongs to keema or whether this is a Scottish cuisine. So to be frank, machine learning is a pretty hard thing to master. It takes a lot of time. You have to learn mathematics and statistics, what's going on behind, and then when you are ready to start developing some cool applications, you realize that you first have to collect a huge set of data, quality data set. You have to label it first. Then comes the training process, which is even more time consuming and a bit stressful, where you have to design your model architecture and train your model, then evaluate its performance, retrain it, and repeat that a lot of times until you are satisfied with the results. And only then comes the part of making predictions with your model and deploying them in real world. So I have hidden all the complexity behind a normal machine learning process in these 3 simple steps. And let's explore a bit more the middle step. So the training step, even though it's a lot more complex than this photo shows, but usually you select a model architecture, you train it with your data, you evaluate. You have some metrics that you are looking for, that whether it is performing good on your data or not, whether it needs further tuning. Then you retrain your model, slightly changing your data set and sometimes model architecture. And when you are ready, you start making predictions with that. But let's say you want to develop a food classifier using the traditional way, the way machine learning models are developed today. So first you have to learn and master deep learning, and then you are going to, of course, have access to huge quality data set, and you are also going to need some GPU machines and a lot of time and patience to train those models, look at their performance, reevaluate. So this story is really tedious, and it takes away the thrill and the excitement that one has when they are starting with deep learning and machine learning. So let's look at how we can make this process easier with the help of Google's Cloud AI offerings. So Google Cloud offers Vision API and AutoML. I think some of the speakers would be talking about Vision API or probably AutoML as well, but let's look at the comparison between these two, so we would be confident which one will suit best for us. So Vision API is usually used for, let's say you are developing an image recognition app. So you want to probably recognize food, or you probably want to recognize cars. You do not have to train any model. You just integrate the Cloud Vision service into your app or website, and you start using it. No machine learning knowledge required. You do not have to train anything. And the service that Google provides is so great in what it does that even if you have millions of users visiting your website or your app daily, the Cloud Vision API can handle all of them. With Vision API, you can detect objects in images, you can assign labels to images, which can become pretty handy in training your future machine learning models. And you can also do text recognition, extracting text from images, and detect logos and brands, detect explicit content from images. You can also detect faces, identify popular places, and let's say you are an e-commerce store and you want to create a really cool search experience for your visitors. So what you do is that you give your users the option to upload an image of the item they are looking for, and Vision API would tell you what item it is, and you would search and serve exactly the right item to your user. And this can be a pretty cool search experience for your visitors. You can also do celebrity search. So where does AutoML come into play? AutoML is one step ahead of uh, Vision API. So let's see how. I developed and uploaded this food classifier. I wrote it with a few lines of code and deployed it in a couple of hours on my website. And it is using Cloud Vision API. And I searched for a few food images on Unsplash. And here you can, let's copy this image URL, paste it, and see what does Vision API think of what's inside the image. Okay, so it says it's 100% confident it's food, dish, cuisine, meal, ingredient, breakfast, brunch, full breakfast, meat. But if this dish has a name, I'm not sure what's the name, but I think it does have a name in some region. The Vision API cannot tell that name. So using Cloud AutoML, we can build such cool experiences for our users that they can not only tell what are the individual ingredients, but they can also identify what is inside. You do not need a lot of data sets. You only need about 100 images of each of the items that you want to predict. And the training is faster, and the model is readily available after training. You can start integrating it into your apps and websites right away. One thing to remember, a famous quote from a machine learning expert and researcher, that your machine learning model is only as good as data fed to it. So it is not always going to be perfect. So the performance always depends on pretty much on the data that you feed to it. So let's see how to build a model with AutoML. We are going to download a few images of some foods. We are going to train them or look how to train a custom AutoML model, because there's not a lot of time to do it right now. And we'll see how to run predictions. So the first thing you are going to need is a Chrome extension. You can search for bulk image download Chrome, and there are plenty of extensions that allow you to download a lot of images from Google Images. And I am using this first one. And let's search for a few foods. Pecan bat. So this is the first food that I found on Wikipedia. That this is known as bacon sandwich in the British in the Great Britain, but this dish is known as this food is known as bacon bat in New Zealand. So how are we going to collect our data set? All we have to do is scroll a little bit, so at least 100 images are loaded, and then you can click on the extension that you install, click download current tab, and Here you can select which images you would like to download for your dataset. We'll not need a lot, but we'll need some quality images. So let's see which ones do not match a good criteria. There's a lot of mess in this photo. This one looks like a beacon sandwich. Let's remove this one, and let's remove this one too. So, and click download. Before you click, you download, it's important that you turn off ask for download in your settings, because it is going to ask for 100 images, and it will ask for 100 times whether you want to download this image, and that would make it pretty annoying. Ask where to save each file. Make sure this option is turned off. So we are going to click download, and it will start downloading our images. Okay. So now that these images have been downloaded, let's look where they are. So here in this folder, that extension has downloaded all the images that we specified. Let's look at them and check whether they are the right ones. Yes, they look okay. So what you will do is that you will rename this folder, the folder in which they are. And so for this talk, I already downloaded 4 different foods, photos of 4 different foods. And the same way, you can repeat this process to collect your data set. And let me show you the photos. So here are a few photos of beacon sandwich, and an important thing that you have to do is that you rename the folder in which these photos are with the name of the food. So I have beacon wrap, beacon sandwich, and here I have keema, and here they are. These are the photos of keema. So you want to have at least about 100 photos of each food, and then you also want to take out a few photos, or 10 or so photos, for the test purpose, because it is important that the photos that you use for eventual testing and evaluation of your model are not the ones that were used or have already been seen by your model. So now what we are going to need to do is we have to compress all these folders into, let's call this dataset.zip. Here we have dataset.zip, and now we can start working with Google Cloud Console. All you have to do is search Google Cloud Console, and you can go to Vision section, scroll down to Vision, and on the Vision dashboard, you have this option AutoML. Click Get Started, and then you have to enable those APIs. So since there is not a lot of time to do that, I'll explain this process through photos. So I ran this, I used Google AutoML for Pakistani foods, the experiment that I did recently. You have to first enable the AutoML API. Then you can, by the way, you can use Google's free tier. They provide about $300, and you can. This is covered within that. You create a data set, and we are going to need a single label data set because we are only interested in identifying what is the photo about. We do not want to label multiple objects because that is a bit costly. And so after the next step is it will ask you for the zip file of your data set, give it the path, and when those photos are uploaded, you will see that it will take you to this screen. Here you have tabs. You will be in Images tab, and on the left you can see all the categories of the foods, of the folders, the categories that you specified. All those images will appear here. Click on each category and select which images are okay and which ones you think are not in that category. Then you are going to the Train tab. In the Train tab, it will give you a nice summary of how many images it has. And so for this category, it is going to use 94 images for so there are total 94 images, and it will use 76 for training and 9 for validation and 9 for testing. So these images will be used for training purpose. Click Start Training, and you define your model name and how you want to host it. So Cloud Host is a good option because that will help you to test this model right in the browser. Click Continue, and your model will start training, and it will take about, when I trained this model, these were about 450 to 500 photos, and this model took 2 to 3 hours to train. But once it was trained, I selected the deployment option, and I am presented with this screen where I can upload an image and see the result of how my model does. So for this model, the dish I used is called biryani. It's a Pakistani dish, and it is pretty confident. It directly predicted with 100% confidence that it is Karachi biryani. This is Lahori biryani, a bit different from Karachi's. These are chanes, and it is 100% confident. This is chicken karahi. It is a famous subcontinent dish, and it is 100% confident in that it is karahi. Same here. This is, however, korma. So here you can see that there is a certain bias in our data set. All the karahi photos, all the karahi dishes are in black fonts, but korma was in white bowls. So what I did was I cropped an image of a korma, zoomed in, and I uploaded it, and it turns out that you can fool even this model if your data set is not good enough. So make sure you remember that your data set is diverse as well as high quality. Even 100 images that you upload are high quality. So that would be it. I hope I explained all the things, and let's see if there are questions. Are there any questions from the audience?
Thank you very much, Emad. That was enlightening. I think you've got a few fans there in the comment section. I think if you guys you've saved somebody a lot of work. I'm sure you can read them there yourself. Thank you so much, sir. And
thank you so much for having me, and thank you for the patience for waiting for me while I figured out how to join the meeting.
I was going to say it's never easy to recover from when the gremlins attack, you know, and
Yes.
you've done remarkably well. Thank you very much, sir, and we look
Thank you
forward to
so
hearing
much.
from you again.
Thank you, Erika.
Definitely
Thank you,
worth the
David.
wait. Yeah.
Thank you. Thank you. Take care.
All right, so we're on to our last presentation for this morning. It is a video, I believe, done by Ayon Roy, who is a data science intern at Lulu International Exchange. He's quite interesting. He talks a lot about using data science for problem solving, and he's mentored in hackathons, and he's written 4 books before he turned 18. So he's a very interesting guy. So I'm really looking forward to this video.
Yeah, I'm not sure I want this. Yeah, this guy looks like he's going to make me feel like I'm less of a person, you know, less of an engineer. 4 books before he was 18. My God, that's some determination. Anyway, we will play this video. I know he's had some technical issues as the theme continues for the day, and that's why we have a recording instead of Ayon being with us live. I know he's watching, so we hope your technical issues come good, Ayon, and you can be a part of more of our streams. Do we want to play the video there, and we can back off to backstage?
Hi everyone, thanks for joining my talk on PySpark combining machine learning and big data. So here we would focus more on to how we can combine the 2 domains of machine learning and big data. So I am Ayon Roy, currently a data science intern at Lulu International Exchange, and I'm really thankful to all of you who joined this GDG DevFest session today. So looking forward to just make this session more interactive, and so that you can learn more, and so that you can understand a little bit more about how PySpark works, or how you can combine machine learning and big data. So I have divided the entire talk into 6 parts. So first of all, we would be focusing on what is big data and machine learning, so that even those who are new to these domains may get a high level overview about what these domains are, or why these domains are so much in demand. And then we would focus on why do we need to fuse big data with machine learning, right? Because it's really necessary that you understood a domain, you know what this domain is all about and why this domain is used, but why there was a necessity to combine these 2 different domains together, right? And that would serve as a base for our entire talk. Then we would discuss what is Spark. So here I'm referring to Apache Spark, and how its architecture will help us in doing machine learning. So we will focus on how the Apache Spark's architecture and the built-ups can be used, can be modified, things like that, to do machine learning seamlessly on very huge data sets. Then we can usually what happens is, when it comes to machine learning or data science, most of the folks are fluent Python or R. So I chose Python, and I would be focusing on how we can harness the power of Spark using Python. Then now, once we get going with by using Python for doing certain jobs using Spark and certain platforms that have been built on top of Spark. So there is a library called PySpark. We would focus majorly on that. Then once that's done, we will focus on how Spark's machine learning library will help us in doing machine learning seamlessly on huge data sets, right? Because in this recent days, the data you have is huge, like it can go up to zettabytes, petabytes of data. So we can definitely see, or we can definitely try our hands that how Spark's machine learning library will help us in doing machine learning seamlessly. So before moving ahead, a short definition about big data. So big data is like, if we talk about big data in very layman terms, it's like where the data is huge, and it's beyond the capacity of a normal machine to compute, normal machine to analyze or extract information. And when it comes to big data, the data that you have, these are mainly defined by the 4 V's. That is volume, that is variety, velocity, and veracity. So when I talk about volume, it's the scale of data. Like the volume or the scale of data is huge, zettabytes, petabytes of data. Then you have variety of data, like the different types of data. Maybe it's an image, maybe it's a text file, maybe it's a log, or kind of that thing like that. So there are multiple types of data that are out there. Then your velocity, the speed at which the data the new data is being ingested. Maybe like if you consider the case of IoT sensors, so they send data at every 5 minutes or 2 minutes kind of thing. So the velocity of data is huge, and veracity is you never know what things would come in data, or whether there would be an uncertainty or not. So veracity in data is huge when you play with big data. So always focus on these four: volume, variety, velocity, and veracity. Now we understood that big data plays with a huge lot, huge lot of data, maybe like which can go up to zettabytes or petabytes of data, which our normal machines would not be able to learn to extract information from. Then when we have these much these huge amount of data, every company in the world wants to extract something, like extract some insights from that data, so that they can tune their offerings to the consumers accordingly, so that they can tune their offerings to the customers, not only personalized in a personalized manner, but also in a general, like they can look into when is the best time to give out offers, when is the best time to give out certain things. So machine learning is like you tell, or you want your machine to behave like a human. We also know that machine learning at this current stage of innovation cannot overtake us as a human, but we are progressing a lot. So in machine learning, what we do is we try to make our computers understand that whatever the data speaks, or whatever insights the data generates. But now we understood that what big data is, what machine learning is, but why do we actually need to fuse big data and machine learning? That's definitely an important point to discuss. So this graph tells you the entire journey of the data generation, right? So if you see that 90% of the world's data that you see now was created in the last 2 years. Obviously, like the penetration of internet, the devices, the people started buying devices, people start buying Alexa kind of devices, and like hell lot of devices. So the data generation was huge, and 90% of the world's data was created in the last 2 years. So when you have these huge amount of data, you definitely want an ecosystem, definitely want a platform to play with zettabytes or petabytes of data. And big data definitely gives you that ability to play with those data and to extract information from that huge amount of, let's say, from the huge amount of things that you have, from the huge amount of from the huge amount of, let's say, data that you have, or maybe like a huge amount of insights that you want to generate from that, right? So when you have these much huge amount of data, definitely you would love to extract information, extract some insights from that, or like you would love to predict the demand of your store or things like that from the previous data. Then machine learning, AI, deep learning comes into picture. So that's why we focus today on combining these two domains, big data and machine learning. So like we now are at a good position that what big data is, what machine learning is, why do we need to combine these two, right? So but when it comes to big data, like machine learning things can, like you understood that machine learning things are done, but when it comes to big data, you play with those zettabytes, petabytes of data. But how would that platform look like, which helps you to play with that zettabytes or petabytes of data? So there was an open source project called Apache Spark. So Spark, if you go by the definition out there in the internet, it's a unified analytics engine which helps you for huge scale data processing, right? Like where the data that you have is huge, like as we are talking about from the beginning of this talk, that the data size can go from zettabytes or petabytes, or even more than that. So Apache Spark gives you an engine, right? So how this engine looks like, we will focus on that, what the architecture of Spark looks like, and how things are there, so that we can also utilize certain features from the Apache Spark's capabilities, right? And then the best part is why people are so excited about using Apache Spark as a big data platform is because it provides high level APIs. So high level APIs in Java, Scala, Python, and R. So those folks who are into machine learning, they might be very much fluent with Python and R. So the best advantage that they get here is they can utilize their knowledge of Python, they can utilize their knowledge of R to play with those features that Apache Spark as an engine provides for large scale data processing. And then on top of that, you have these 4 features: Spark SQL for SQL and structured data processing. Like you can make SQL like queries to query the data that you have, like maybe the data size is huge, right? So you can store your data, things like that. So how the combination, how the how this all things work, we will definitely focus. Then you have ML for machine learning things. That's our major focus today, ML. Then you have graphics for graph processing, and then structured streaming. Let's say your company deals with some IoT sensor devices, so it helps us like there is a high chance that you would be playing with streaming or data streams. So Apache Spark gives you that flexibility of structured streaming for incremental computation and stream processing. So this is Apache Spark, and Apache Spark is now an open source project, and it was started in university like UC Berkeley. So now people have been like contributing a lot to this ecosystem, like Spark ecosystem, so that you can utilize the functionalities of Spark in large scale machine learning or deep learning kind of things. So we were focusing on these things, right? So Spark SQL, MLlib, graphics for graph processing, then Spark streaming for all streaming related things. And you can save your data, like maybe the huge amount of data that you have is stored in, let's say, MySQL or Cassandra, Hadoop. So you can store your data in these data sources, right? Then you can call the data that has been stored in these databases through a data source API, and you can utilize all the functionalities that Spark provides. Maybe it's a Spark streaming, maybe it's a graphics, maybe MLlib, maybe Spark SQL. So it was about Spark, right? The platform that we were talking about, which helps us in doing machine learning, which helps us in big data processing, and it provides us an analytical engine. But what and how the Spark's architecture looks like, because it's important to know that, because otherwise it would be very tough for us to like understand how we can utilize the potential of Spark for machine learning. So we would definitely love to see, and we would definitely love to explore the architecture of Spark. So this is how the architecture of Spark looks like. At the very bottom you have the like clusters, right? Because this is the ecosystem that Spark provides you, that maybe you have a standalone cluster. Standalone cluster means you only do things with your own single machine. But maybe when your company is huge, maybe you want to utilize the potential of big data on a huge amount of data, like let's say you are Uber like company. So you have huge amount of data, and that data cannot be put in a single machine, and it's distributed kind of thing. So you can make a cluster on Amazon EC2, maybe Hadoop Yarn clusters, maybe Apache Mesos cluster. So you can make all those clusters. So clusters is just like maybe you get your data, you have huge amount of data, you just divide the data into multiple chunks or multiple paths or multiple parties, right? So once that ecosystem is ready, you do not have to code it, or you do not have to set up all those things. It's highly accessible. It's highly like today today it's very easy to set up a cluster, Spark cluster. If you talk about Spark cluster, you have multiple options, maybe standalone, Apache Mesos. So you do not have to take care about all those things, internal functionings of Spark, because that's what the open source project of Apache Spark looks upon. They focus on the division, they focus on clustering and things like that, how the things would work in the backend. Now, once you make that cluster, you would love to utilize that cluster to do some computation, to do certain analysis on the data that you have. And in your case, maybe the data lies in HDFS, that's Hadoop Distributed File System. Maybe the data lies in Cassandra, maybe the data lies in MongoDB. So you can use the data source APIs and can call all those data into Spark Core. So once the data is in Spark Core, you can utilize the functionalities of Spark Core, which has certain like internal functionings of Spark, like how things work, or how a job which Spark gets is divided into multiple parts, or like what the things are. We will definitely look into the next slide of how Apache like Spark code looks, and how the work that is induced into the Spark architecture takes place. On like once that architecture, like once that work is divided, things like that. So now you would love to work work using the libraries like streaming library, SQL, MLlib, graphics. So you can utilize all those things. And on top of that, how you can interact with the Spark core, how you can interact with the cluster, it's through the languages, right? Language APIs. Maybe like my preference is Python, so we will be using Python for utilizing the libraries like MLlib to interact with Spark core. And in Spark core, the data from multiple sources, maybe it's a MongoDB, Cassandra, HDFS, comes in, and you have the variety of clusters. But we were discussing about that in Spark core, the entire like the how a process in Spark's architecture takes place, how a Spark job is run, right? Whenever a work or whenever a task, that's called job. So whenever you give that job to the Spark core, how the things work, what Spark helps you with, we can definitely look into it. So let's say whenever you have a big task, let's say you want to throw a party to your friends and you invited 15 of your friends, but as an individual it's very tough to prepare all things in our home and to throw a party to our friends. So what you did is, like, you called upon your mother, father, and brother, right? So you told them that, hey, I am planning to throw a party to my friends, could you please help me to do certain stuffs? So they would like, you allocated that you are the driver here. So driver is the person who just knows what things to do and what they expect, right? So once you know that, in your case, you know that you want to throw a birthday party, then you then you throw that information, you throw that instructions to the cluster manager. Why this cluster manager is important? Because let's say you thought that your mother would bake the cake, your father would clean the room, and your brother would help you in, let's say, in buying certain chocolates or things like that. So you divided that task. But how will you know that when a person to whom you have allocated the task has done that task, right? So you should keep a track of whether that task has been done which you allocated to someone. So this cluster manager, like, you know what you want to do and you know what the output should be. You divide it, you send that instruction code to that cluster manager that, yes, I want these things to be done, and these are the workers. So let's say the worker one at the very top is is looking for some data preparation kind of thing, and the second worker is looking for some data cleaning, and the third one is looking for data pre-processing and, like, let's say, ED and modeling, right? So whenever worker one does this task, it sends back the result to cluster manager, and then cluster manager combines all the result from different workers, and they send back result to the driver. So this is how a Spark program looks. So a Spark program that you write is the driver. It knows the variety of tasks it has to do. It then divides the task into multiple workers, and every worker is associated with certain executors. So executor is like, that keeps in mind that which of what things to execute and how things to, like, how things should be executed, be it using certain libraries of Spark, be it using certain other libraries or certain custom made codes. So this is how Spark works. So if you want to read about this, like what is Spark context, what is driver, what is executor, you can definitely read this, read this at a later point of time. I will tell the organizers to share the slides with you. But now you know that how Spark's architecture looks like and how a Spark job works, right? So now you will be at a better position that, yes, I would now plan to use Python and Spark together to gain something awesome, right? You can utilize the potential of Python, you can utilize the potential of machine learning, which the Spark already provides, like the Spark's machine learning library that we were discussing at the initial points. Then how you can utilize that thing? So we were discussing this this architecture at the very first, right? So this is how the things look. We will be focusing majorly on the Python, and in that bottom of Python you have MLlib. So that's our major focus today, Python plus MLlib, and then we can do all our processing. Then we can do all our processing through Spark as a platform. And you now know that how a platform Spark as a platform helps you to do certain things, or certain data, like big data plus machine learning things. But how actually these things work, it's actually that Sparks, like, you now will be utilizing a library called PySpark, right? So what PySpark is, so PySpark is a library, like you have certain libraries in Python, maybe NumPy, Pandas, you might have heard about those things. So Apache Spark was actually written in Scala, but to support your work, like whatever you work, whatever you do your work with Python. So but how should that interact with the bare bone structure of Spark, or the bare bone structure of the ecosystem that the Spark provides? So what happens is, like, Spark context, maybe the driver that we were discussing. So you know that task that we want to do certain machine learning or certain recommendation kind of thing. You just made that task available in the driver. You made a Spark context through socket. Is like, socket is for connection, that yes, I allocated this task and I got back the result. So what this Py4j is, Py4j is a library, or it's a library that helps you to bridge the gap between Python and Java. So like all the blue boxes that you see here are, let's say, JVMs, Java Virtual Machines, because whenever you install Spark, you need to install Java, like you need to install Java too, because that's how the Spark ecosystem works, and that's how the Spark ecosystem has been built. So you made a Spark context, and you are communicating through a socket, and through a socket you just gave your task, and that task was divided into, let's say, multiple workers, right? You see that Python workers, like like the Spark workers, the 2 Spark workers that you see. So these are also interacting with each other. Maybe like one worker needs the result from another worker, and then these things work. And then the task that you told, that maybe data cleaning, data processing, or maybe some machine learning kind of things, you just make a pipeline and do those things in Python. And once the results are back, you send back to the Py4j Spark context, and then the result is thrown back to the Spark, the main Spark context. That's the driver. So this is how PySpark would help, or this is how we, whenever you write that import PySpark and you do your PySpark job, so this is how the things actually look like. So it's all through that Py4j library that you have. But this was till now, this was how like PySpark, we learned more about PySpark, how Spark works, or what's the architecture of Spark. But we were also discussing about the 4 functionalities that Spark provides: machine learning, ML lib, graphics, SQL kind of things. So how things would work, or like what should be our main goal towards that. But when we now also know that Spark has this functionality of machine learning, Spark has, like, we also know that there is a library called PySpark which can help us to do those things. So whenever we talk, this is the things, like these are the few things that PySpark provides. So you have the machine learning algorithms, like whenever you install, like whenever you use PySpark, and you would be utilizing that machine learning library, MLlib, that we were talking about. So that's the Spark's machine learning library, that whenever you talk about those things, so you have that MLlib. So in MLlib, you have these functionalities, ML algorithms. So if you know about ML algorithms, there are regression, classification, clustering. So you can utilize all those algorithms which are pre-built there, and you can tweak it as per your demands too. And then you may do feature engineering, feature extraction, then dimensionality reduction. These are all things for machine learning. And whenever you want to do a machine learning thing, you make a pipeline that after this process you should do this thing, or after do this thing you should do that thing, right? So then you have persistence, like you can make your models, you can save your models, you can save your, like you can just load the algorithms, load the models, and make the work done, right? Because you do not want to write it again and again. So MLlib in Spark ecosystem provides you these 4 features: ML algorithms, feature engineering kind of things. Then you have pipelines, persistence, and the utilities like linear algebra, statistics, data handling kind of things. You can definitely look into those. So this is how a Spark's ML workflow looks like. So you just train your data, like you just ingest the data, then extract the features, then make a model, and then evaluate it, right? How your model is being evaluated, or like how your model is performing, it's on the basis of accuracy, things like that. So you can do all those things with like this is similar to a machine learning process, but with the help of the ecosystem that Spark provides. So you have data frames. Transformer is like you take a feature and convert it into another feature, or make a new feature kind of thing. An estimator is where you make a model, and evaluator is where you evaluate how your model is performing, or what's the accuracy of that model. And this is the pipeline. How a pipeline is like similar to machine learning pipeline. You just divide the entire task into multiple stages, be it stage 1, stage 2, stage 3, stage 4. And at the very end, you just predict something, right? Maybe like you want to make a dog versus cat prediction, or you want to make a classification kind of thing, or you want to predict what the sales of your store would be. You can do all those things, and you can just define all the stages in your pipeline. So if you want to study about those data frame, transformers, estimators, pipelines that we were discussing, right? Here we had data frame, transformer, estimator, evaluator. You can just definitely go and focus on. And then this is the closing thing, that what does the Spark's machine learning library consists. So these are all things, that logistic regression, linear regression, lasso regression. Then you have support vector machines. These all things are already contained in Spark's machine learning library, MLlib. So you can always utilize those functionalities, and you do not have to take care about how the architecture would look like, or how the division of things would look like. So it's all okay. And it's very easy to to plug the gaps between machine learning and big data. And I hope that this talk can be a starting point for you, and you can just move ahead and explore a little bit more about this Apache Spark, big data, and machine learning. And I have provided some useful resources. You can just definitely look into them. And if you have any doubts, like you can definitely let me know. It's go for it, just right. So it may be daunting for you at this point of time, that this talk was quite fast, or kind of things like that. But now you get a high level overview of what things are, and I definitely look forward that you also try to utilize things. You also try to utilize the functionalities that Spark and machine learning can together provide. And if you have any doubts, you can definitely reach out to me on my email and LinkedIn. And thank you so much for listening. I hope that this virtual DevFest also works well for you, and you learn a lot of things. So stay safe. Bye-bye.
Well, that was great.
Yeah, that was fantastic. That was a fantastic talk. And as Ayon said, if you do want to explore Apache Spark, we do have another talk on Apache Spark by Daniela Petruzalek at 5:45 over on the Hot Tech track. So I bet you'll pick up a few more useful tidbits there. And she's a fantastic speaker. I encourage everybody, if you're interested, to go and see her talk. Ayon, we hope your connectivity issues remedy themselves soon, and that you're watching us live, if you're able. Erica, any final thoughts for this section?
Yeah, if you're going to be tweeting about this, don't forget to tag us. We've got hashtag DevFest and hashtag DevFestUKI. So we are looking forward to hearing about what you guys think, what really jumped out at you, what you want to hear more about.
Yeah, amazing. So yeah, now we will enter a short lunch break. And now after those talks, I think we're all hungry with the good food detection talk. So we'll be back in a little bit, okay?
Yeah, I'm over on the Cloud track next at 2:45 with Jennifer Pedoff, head of SRE at Google. If anybody's interested, jump over to the Cloud track for that. Erica, have you any other duties for the rest of the day?
No, I get to just tune into whatever I want now.
Oh, yeah. Fun. How about Ricardo? You're minding the whole track for the whole day. You're doing a fantastic job. Thank you so much.
You. Okay, thank you, guys.
Hey, guys. See you after lunch.
See you.
Hello, everyone. I hope you had warm lunch. My name is Shadab. I am from GTZ Galway. I am also a software developer at IBM. Ricardo, would you like to introduce yourself quickly?
Yeah, sure. So this is Shadab, and well, I'm Ricardo. I started hosting this AI/ML track, and yeah, right now we will introduce our new speaker, which is Sachin. He's helping us from Tuple Life, and yeah, let's just bring him in.
Okay, yeah. Before Sachin comes in, just let's talk about the lineup. So if you had lunch and you're feeling a little sleepy, promise that this slot is definitely going to keep you awake. So we have great speakers lined up, interesting topics to talk about. So we will first talk about intelligent actions for Google Assistant, followed by another one, Google Video Intelligence API. And the last but not least the talk, we will go to the other side of the system and talk about the DevOps of machine learning. So let's jump up to the first talk of this slot, and you are going to learn how to build a conversational action for Google Assistant. So Sachin is a Google developer expert, and like Ricardo mentioned, he is a CTO at Tuple Life, and he also runs Chatterjee Doha. He has vast experience in mobile web, AR, VR, voice, and cloud computing. So, okay, let's not take much time, and Sachin, the stage is yours.
Thanks a lot, Shadab, and thanks, Ricardo, as well. Once again, thank you all for having me. For today's session, we'll actually learn how to build intelligent actions for the Google Assistant using machine learning and actions builder. So a quick introduction again. Once again, I'm Sachin Kumar. I'm a Google developer expert, especially from the Google Assistant. I'm also the Chief Technology Officer of a company called Tuple Life, which is a connected healthcare company based out of Dallas, Texas. I also head the Google Developer Group's Doha. With that being said, you can definitely get in touch with me through Twitter. And I do write a lot of tech articles and blogs, so do check that either in my website or through Medium, if you prefer that. And finally, coming back to YouTube, as part of the whole pandemic situation, this was something I recently started just to connect with a lot of participants across the globe to kind of go through a learning curve instead of just having specific sessions, to actually go step by step and be part of the whole developer series or journey. We have multiple tracks over here, from AR, VR, web, mobile, cloud, machine learning, mobile, and web. So make sure that you guys go to YouTube and check out Tech with Such. Click on the subscribe button so that we could be connected. So we'll be doing these weekly sessions and live streams as well. So make sure to subscribe to the channel. So before we actually get on to the whole thing, most of this talk is actually based on tutorials that's already available in my channel. So from here, I'm just going to give you more of examples and demos, and also some live walkthroughs of the new tool, which is the Actions Builder. And from there, we will actually go and take it a step further and see how we can actually combine it with machine learning APIs and other external APIs to make it more intelligent. So for everyone who's joining us live, once again, thank you all for joining. And to begin, I would actually talk about Google Assistant. So for folks who are not aware of what Google Assistant is your own virtual assistant from Google to get things done for you in the most helpful manner. So what does it mean for developers like us, right? So why would we need to focus on the Google Assistant platform? The thing is, the Google Assistant is already available across 1 billion plus devices. And again, this could be outdated. It could be a lot more than that. So the idea is, you as a developer or an organization or brand has access to reach to 1 billion plus devices by building for the Google Assistant. So that's the true power behind the whole platform. And we have a growing audience in terms of the language support in different countries. Again, this is just a small snippet of what are the available languages, and we have much more added on a day-to-day basis. With that being said, let's actually understand what are the different platforms or parts of the whole ecosystem. So one, we have the Google Assistant, which, as I said, it's your own virtual assistant from Google to get things done for you in the most helpful manner. Then we have devices built with Google Assistant. So you have your Android phones, iPhones, your smartwatches, your smart speakers, smart displays, all of those integrated with the Google Assistant. So you have access to kind of leverage on those connected devices. And then you have Actions on Google. So Actions on Google is the developer platform that lets you define and fulfill actions that users can invoke. So basically, Actions on Google is the platform that we'll be using to build actions for the Google Assistant. Now, the Google Assistant has multiple parts. We are actually covering the conversational part. So how can we build conversational chatbots or voice assistants for the Google Assistant? In the voice world, we call it actions. Instead of applications, we call it as actions. So when we're looking at the entire flow, what is the sequence of things that happens? So as a user, when you're talking to Google Home, I have one over here, or any Google Assistant integrated device, you're actually giving your voice input, which gets converted into text by the Google Assistant. So Google Assistant is in charge of handling all the NLU, natural language processing, converting your voice to text, and then passing it over to your side, which is your action. Now, your action would basically receive it. You would pass the information and say, okay, based on this is what the user is trying to say. So let me give back a response. And that response is again handled by the Google Assistant and then given back to the user. At any point, if you feel you have any queries or doubts, feel free to leave your comments in the chat section, and I'll be more than happy to answer that. So when we actually started our talk, I actually mentioned about a new way or a new tool to actually build Google Assistant. So what was the old way of building conversational actions? So the old way was actually using Dialogflow. So if you were aware of Dialogflow, Dialogflow is still a platform, excellent platform for building chatbots and voice assistants, and integrate with other platforms as well. But in this case, before we used to actually build the entire action using Dialogflow. And with the new tool, which is called the Actions Builder, we have a much more native way to actually build conversational actions. And one of the reasons why I want to make sure that talk or session today is more hands-on with a lot of examples is also the fact that you'll kind of get a hands-on experience of how exactly or how easy it is to actually build conversational actions. So Google recently launched the Actions Builder, and I'll exactly come to the point why they did that. While the Dialogflow was an excellent tool, it was already handling that. So Actions Builder gives you a powerful and easy to use web-based IDE that's integrated into your Actions console. So here's a small example of what the Actions Builder looks like. So on the top, you have the top menu. So overview, develop, test, deploy, and analytics. And the reason why Google actually started thinking about in this approach is before, if you have to build an action for the Google Assistant, you had to switch between two different platforms. One was Dialogflow, and now you have the Actions on console is where you actually build your action. So as a developer, you had to switch between two different platforms back and forth to test out and check everything. Now with this, you have an entire access where you actually go through from creating your action to actually building it, testing it, deploying, and finally even analytics of how your action is performing is all integrated into one platform, which is the Actions console. So with the Actions Builder, you actually have the top menu. This is what we covered right now. And on the left side, we have the list of all the components like intents, scenes, etc. This is the build area. We have the data visualization. So for any components that you click within this main area, you will also find like a details area over here. Okay, so this is how an Actions Builder UI would look like. So before we actually start building something, let's also understand some of the basic building blocks of how to build conversational actions. So these are some of the new concepts that's introduced in the Actions Builder. So scenes. So scenes are nothing but building blocks for your action that processes user input, typically generates the response to the user. So basically what it means is think about scenes as each block of your conversation. So when you're building a conversation or designing a conversation, it's very important that you actually build it based on different scenes. So think about the first thing, what would you do to the user when the user says, talk to my test app or talk to any specific action name? The first response is the greetings, right? So you'd greet the user. So that can be one scene. Then from the greeting scene, based on what the user selects, you can navigate to another scene. So these are basically called scenes. So custom intents. So think about custom intents as it defines user input that the action can understand. So anything that you create custom intents in a way that if you're looking at what are intents, basically when a user is having a conversation, you need to understand what is the intent of that specific conversation by the user. So we create custom intents where we say for this specific intent, these are the training phrases. Okay, so these are the training phases that we need to provide. So this might be something very similar to what the user would say. So I need to train my machine learning model based on these training phrases. And once those training phrases are saved, my intent, whenever the user is giving a specific conversation, based on the conversation, the assistant NLU will understand that, okay, this specific conversation means this specific intent. So those are basically intents and training phrases. And transitions. Transitions are very simple. If you want to transition from one scene to another, it defines how you can transition from each scene, from one scene to another based on conditions and other features. So with that being said, let's actually start building, and then we can actually learn along the way. So the first step to do is go to console.actions.google.com. Gonna make sure that I choose the right account. So I have one account which is already created here, one project. You can always go ahead and click on new project and start building. For the purpose of time, I'm just gonna click one which is already created. So over here, you can see that we have, this is the Actions console. We have the overview, develop, test, deploy, and analytics. Now, as a conversation designer or builder, what you need to do is go through all of this. So if you kind of go through the quick overview over here the display name defines what your action should be. So this display name or action name is basically what you would define your action as. So let's say talk to Dr. Music, or talk to Uber, or talk to one specific, your action name or your application name is what you need to define here. Again, there are different things that you need to take into consideration. All of that is available to you in this help section. Every section has a help tool so that you can actually click on it and understand or learn more about it. So we are actually in the develop tab right now. And if you actually look at it in terms of sequences, we have settings, main invocation, we have scenes, intents, types, everything. So everything is kind of laid out to you properly on the left side navigation. And based on what you click, you kind of move on to each conversation. So over here, you can see that on the scenes, even before we go to scenes, let's actually go to the basics. The first one that gets triggered is your main invocation, which actually brings us to a very interesting concept over here of how the entire actions builder looks. So here you can see the actions builder also gives you, I would say, more like a wireframe or a conversational flow design to easily understand what exactly is happening. So you don't need to actually do any bit of coding to actually build conversational actions, apart from the fact that if you have your own backend, you can actually do that. The next one is as the whole thing about the actions builder is also the fact that if you are not building alone, you have a team who are actually working on one specific conversational action. Now you have the ability to actually pull down this entire project in the form of, and using Actions SDK, you can actually share this whole project with your colleagues and teammates, right? So it's actually a way for multiple people to actually work with each other. So think about from Google's perspective, they were thinking about from conversational designers. So the designers would actually come here and design the whole conversation. And then from the developer standpoint, they can exactly pull down the entire project and have it like a file-based system where they can actually go ahead and make those changes or connect to the webhook, do all the backend logic behind the scenes. So now with the main invocation, so whenever the user says talk to the test app or the invocation name that we gave in the first place, it will then invoke your action. And what happens is when I click on this, so if I hide this away, whenever you click on this, what should happen? So the moment I click on the invocation name or your action, the first thing that's happening over here is greetings, right? So over here, you have multiple options. One is call your webhook. The other is called do a send prompt. So just for the sake of testing and demo, I'm just gonna choose send prompt and I'll show you exactly what happens. So over here, I'm just gonna type in welcome to DevFest. Okay, and I'm gonna save this. Now, I don't want the webhook to be called at this point, so I'm just gonna uncheck this specific part of it. So what's gonna happen is whenever we are gonna test our application, invoke it, it will then come to this section where it will see that, okay, there's a send prompt here. So send this back to the user, so which is welcome to DevFest. So the moment we do that, let's go ahead and see what happens after that. If you come down, the next step is transition to the start scene. So the moment if I click on the start scene, it will actually open up the start scene over here, which is basically referred on the left side navigation as well. So this is the start scene. So we have 3 scenes over here: start, fortune, and again. Again, all of this code along with step-by-step tutorials all available on the YouTube channel, Tech with Such. So you guys can it's actually split into 2 different sections, Code Lab 1 and Code Lab 2. And then I have a full-length video with everything covering about Actions Builder and Actions SDK. So coming to this start scene, you can see the moment you enter, transition from the main invocation, what's the first thing that it does? It sends a prompt. So again, this was part of a conversational action, which basically is like a game based on fortune. So this gets this gets automatically added onto the prompt. Now, to just actually show you what exactly happens when we go ahead and test this action, So we should be actually seeing two things. One, a custom message that we just added, which is welcome to DevFest. And the second, the moment it transitions to the start scene, there is another message that pops up. So that should be what we should be seeing over here. Now, when you click on the test tab, you have this option. So you have multiple options over here. So on the right-hand side, this section is called the event log section. You'll see exactly what I mean by that. And you also have, it's not necessary that for building conversational actions, you need to have smart speakers. You can actually go ahead and try these out directly from the test simulator. So you have smart displays, phone smart speakers, and KaiOS to test with. So I'm just gonna keep it to smart displays, and I'm just gonna trigger our test application right now. So if you have not given a display name or an action name, it's gonna be called test tab, right? Talk to my test tab. So let's trigger that. So here you can see that, okay, getting the test version. Welcome to DevFest. Before you continue on your quest, would you like your fortune told? So based on yes and no, again, these are suggestion chips that we have added within our actions builder. Depending on that, it would actually go to a different scene. So here, as you can see, this is a different scene altogether. And all of this is actually happening behind the scenes through the conversational flow. So if I go back to the start scene, we came over here, which was basically before you continue on your quest, would you like your fortune told? And the yes and no that you actually saw on the screen is based on these suggestions, right? So you have both options over here. Either you can represent it in YAML or JSON format, whichever you're comfortable with. Now, what actually happens after that? So we have, then you have, based on yes and no, you need to actually switch to different scenes. But how does that happen, right? So for us to understand when the user says yes, we need to actually understand the intent of the user. So that's why we have intents over here, which is called yes and no intent. So if I go and click on yes intent, which I've created over here, you can always go and create more intents over here by clicking on this plus icon. But if you actually look at what the yes intent does is, I have few training phrases that I've already provided, like tell me, I would, why, and yes. And then below that, you can also choose to add different parameters if you want to extract any information from here. So if you go to the no, all we're saying is, these are the training phrases that we are providing to the assistant NLU, so to the machine learning model, to understand whenever the user says something similar to this, it means that it is no intent or yes intent. Now, based on these yes and no intents, if you go back to the start scene, when we click on these custom intent handling, when a yes is matched, transition to the fortune scene. Again, we have another scene with little more conditions and other things going on. I don't want to get into that specific part of it because then we'll need a little more time to explain that. If it is no, then basically end the conversation. So that's what is actually happening behind the scenes. So this is the actions builder as such. Now, with this new tool, the actions builder and actions SDK, both designers as well as developers have a great way of combining and working together to build beautiful conversational actions. You can also use things like SSML, speech synthesis markup language, to actually add more sound effects and audios and kind of have a different pitch to your action so that it actually is more engaging rather than a simple response. So going back to our slides. So what I would like to do next is shift our focus to the next part, which is how do we actually take it to the next level, right? So we have, how can we build intelligent actions using machine learning APIs? And to kind of take it a step further, how can we actually use Google Cloud Machine Learning APIs, integrate other external APIs like Twilio, and kind of build meaningful applications. So I have a demo in store for you guys. So hopefully it works. So I have the Google Home over here. I'm just going to talk to the Google Home. So this is a test project that I did. Hey, Google, talk to my test app.
Okay, let's get the test version of my test app. Good afternoon, Sachin. Let's see how you are doing today. On a scale of 0 to 10, what is your pain score right now?
Cancel. So let me actually also show you what it looks like in real time. Okay, so we have, hope you guys are seeing my screen here. So we have this specific window. So the idea behind this action is we are going to ask a patient a set of questions. And based on those questions, we are also going to capture the sentiment of the user. Okay, so based on that sentiment, you should actually see the screen refresh and these values change. So let's actually give it a shot. And also, there will be something that's happening on my phone at the same time. So it's a sequence of events that's going to happen. So let's start again. Hey, Google. Hey, Google. Talk to my test app.
Okay, let's get the test version of my test app. Good afternoon, Sachin. Let's see how you are doing today. On a scale of 0 to 10, what is your pain score right now?
7.
How did you sleep last night?
I didn't sleep at all.
Describe any side effects you are experiencing from your medications.
Probably nausea and headache.
Okay, how has your mood been over the last 2 weeks?
Oh, it's been really, really bad.
It sounds like you should talk to a trained mental health professional. Here is the nearest one, Providence St. Vincent Med Center, and you can reach them at +1 50321 61234.
Okay, so you can see that I'm getting a call at the same time.
Good afternoon. Patient Sachin submitted a pain score and is in need of a follow-up call.
Okay, and I did also receive an SMS as well. So the thing is, if you looked at what happens behind the scene, based on the queries or the responses that me as a user interacting with the action, I'm capturing the conversational data, and then I'm actually using something called as sentiment analysis, which is a Cloud Machine Learning API. So if you go and search for the Google Cloud Natural Language API and try this one out. So this is a Google Cloud offering, which is an API where you can actually use this and extract the sentiment of the user. So let's load the default one. So analyze. So with this simple sentence, it can identify the entities of the contents that's there within the sentence. And if you move on to sentiment, you can see the overall sentiment score of the document. The whole document is 0.2. And then based on different sentences, you can extract different values. So over here, when we did our demo, you could see that it went to minus 0.8 because of the feedback that and based on that feedback, we got an automated call that came in using Twilio and as well as an SMS. So you can actually kind of mix and match different combinations of all of this. And the way how you can also do all of that is by going into webhook, and webhook will allow you to actually connect your own backend to it. So either you can use Cloud Functions or your own webhook and call these external APIs and make meaningful applications out of it. So I think we've almost come to the end of our talk. I have little more demos that I wanted to show. So this was one where I'm actually controlling the Google Home. So when I say, hey, Google, it's TV time, it will automatically turn on the projector, turn off the lights or dim the lights, switch to the right source. So I have like Xbox as well as the other channels connected to it. So it will switch to the right channel and then start playing. So you can actually control your other things like in terms of, so over here I'm saying, here I say it's cleaning time, and then you can actually see the vacuum robot actually start cleaning. So these are just simple examples of home automation using Google Home. The other cool thing that you could also do is you also have the ability to build actions directly on your own hardware. So this is an example where I've built the entire Google Assistant inside the book. So from the outside, it just looks like a book, but it's actually, you have the entire Google Assistant inside the Raspberry Pi, which is inside the book. So with that being said, if you want to follow all of these tutorials step by step, all the resources are available in the slides. And you can also watch the full tutorial in my YouTube channel. So looking forward to seeing you all in the weekly sessions and videos. So with that being said, let's connect. Thank you all for having me. And that's all I had for today's session. Thank you all.
Thanks a lot, Sachin. It was really a wonderful talk. And the demo was really cool as well, very interesting. We didn't have much time, but sadly we could not see the whole demo, but it was really cool. So maybe people will follow your YouTube channel and they can find more about it, more demos.
Yeah, thanks a lot, Shada.
Yeah, thanks, Sachin. Okay, guys, so as we are talking about intelligence in the previous talk, how about making it more interesting? So think about it. Maybe you want to detect duplicate content between different cuts of the same film, or maybe finding different films with the similarly themed content. So our next talk is just going to be really very interesting, and it's titled as Google Video Intelligence API and Film Disambiguation. Let me bring Bruce on stage. Okay, so Bruce is a Google developer expert, and he's also a consultant at Pipada Consultancy. He was previously head of architect and IT engineering at Motorola and Lucent Technologies. So he's a very experienced guy, and he's also author and speaker on Google technologies. So Bruce, I'll not take much of your time. The stage is yours.
Thank you. Well, it's a pleasure to be able to participate in again, in DevFest. Normally I talk about G Suite, or now as it's known, Google Workplace at these events. That's my main Google developer expert specialist subject, but today I'll be sticking to the Video Intelligence API. So I've been a fan of this API since it first appeared. I think it was about 3 years ago now, recognizing the great capability it would bring to our little film industry startup. So I'd love to share some things that I've learned. I won't be showing code here, though. In fact, the API itself is really a model of simplicity to configure and use, but rather I'll share some concrete examples of how we use the results from the Video Intelligence to enhance the search capabilities of our database of commercials, making them content searchable. So the Video Intelligence API is a Google ML product, but it comes with a set of pre-trained models. So they call these features. So you just have to point your video at it, and it returns a vast treasure trove of data about its content. It's very straightforward to use. So your job is pretty much just to dive into it and organize the results. So that's what we're going to do in this presentation. So they're called features, these capabilities within Video Intelligence. And so let's look at the different features that you can, well, that I use. There are a few more than this, actually. So it detects shot changes. Now, a shot change is a scene change in a film. Sometimes it's known as a keyframe or an edit point. A scene might last anything from a second or two, or maybe longer if it's a long camera tracking shot and it's moving for a length of time. It could even last the entire length of the film, a single shot. So you'll be familiar with the concept of labeling. That's recognizing objects and assigning an entity ID to that object that it's recognized. Now, VI can do both these at shot change and also at each individual frame. So a frame would be, you know, a film might have 25 frames a second, and a shot typically is going to last for a few seconds. You're going to get a lot of frames within a shot. Now, it can also transcribe speech and recognize text. But best of all for me, it can track an object from the frame it first appears in through to the time it disappears again. So tracking means linking the object entity ID to a time, a normalized position in the frame. And this is the key capability for film disambiguation, which will, the main subject of this talk, which you're going to get to later. So let's take a look at the workflow required to translate a film into usable content data. So uploading a film to RRAT triggers a series of microservices, and they're all glued together with PubSub. So what happens is that the film gets cloned to cloud storage because that's where the Video Intelligence API works off of. We select the labeling features that we need. So that would be like transcription, labeling, etc. We send a request off to the long-running API because the labeling is done not on your own VM, but in some mysterious backend somewhere in the cloud platform. And then the next microservice receives and formats the result, organizes it to a database, and updates Elasticsearch indexes, which make it available for querying. We use Elasticsearch in the backend for querying. We've got like millions of labels that we need to look through, and Elasticsearch is pretty good at doing that. Now, a typical 90-second commercial will eventually create around 1,500 database rows from it in the way that we've organized the data. So this is what a search would look like in the UI. So in blue, I've overlaid a kind of a tooltip to show where the matches actually come from. So this query is looking for films that feature cows and chickens. Quite an unusual combination, but there you go. So notice that some of the relevance matches, which are the things that are highlighted in the Elastic Index results, come not only from images of cows and chickens that the Video Intelligence API has detected, but also from dialogue transcription. So it's detected that somebody somewhere in some film has been actually talking about cows, as well as there being pictures of cows. So now that we've got our searchable labeling data, we can use it not only for searching our film database, but also for some other stuff, such as navigating to particular parts of the film that feature content that we're interested in. So here you can see how many labels were detected of each of these types of films. So those labels are, of course, the same as the video intelligence features that I've selected for this kind of analysis. So when we open up those shot labels, you can see there's a whole bunch of labels on the screen there. We can see what's been detected at the beginning of each shot, of each scene in the film. And we can navigate to any one of those places. So we just click on the label, it will take us to that point in the film, and we can just skip around and look for poultry and animals and cattle or whatever we're interested in finding. Because we've recorded not only the fact that there was a label, but when it happened in the film. So labels have also got the concept of confidence. That means how sure video intelligence was that the label has been accurately identified. So here I've elected to consider only labels with a confidence levels of 70% and above. If I was to move that slider down a bit, I would get a whole bunch more labels that video intelligence was a little bit less confident about. So this entity ID that video intelligence assigns to things that it's recognized, it's very helpfully, this is actually the Google Knowledge Graph MID. So that means that we can easily pull in the complete knowledge graph entry for that entity like I've done here, including its Wikipedia page, etc. Now, interestingly, the knowledge graph is what Google displays when it provides enhanced info in the search engine. You know, when you do a Google search and you sometimes get a little box with extra stuff in it, that's directly from the knowledge graph API, which is what I'm using also. So I've just, so you can see here, I've pasted in the result of searching on the same term on the search engine, and it's exactly the same as I've picked up from the API. So that's a rather pleasing symbiosis there. So because we've got a note of exactly where shot changes happened in the film, we can quickly review a film by skipping through the scene changes. So if we were to click on one of these times, these are times and seconds into the film that you'll find a change in scene. And we can skip through the film quickly by just jumping through, clicking on these. But even better, using that fast forward button there, we can review the entire film by looking at this, what happens at every scene, without actually having to watch the whole thing. So we can get the sense of the film without having to watch it. Another thing that's very nice is this text transcription, but also dialogue transcription. So written text is translated into text, but dialogue is also interpreted and returned as text as well, as you can see here. And it also attempts to do what they call speaker tagging, which means that if it detects that the same person says something somewhere and then a few minutes later the same person says something else, it assigns a speaker tag to it. So you can follow a conversation between multiple people and see who said what. So in this example, I've denoted them as voice A and voice B and so on. But what I'd like to do in a future enhancement is to tie this up to the film metadata. We have lots of metadata about each film, like who was in it and who directed it and all this kind of stuff. I'd like to be able to tie up the film metadata to the character that said it and the actor that was playing the character. And then that way we can create a nice profile for actors about every film they've been in and what they said in the film, and allow you to skip between the films they've been in and what they said and when they said it and all this kind of thing. So that's a really great feature. It's going to take a little bit of time to do that, but I think this is a nice enhancement. So it does logo detection as well. So we've looked at all the main features now, and this logo detection works in exactly the same way. It finds a logo that it recognizes and gives me a Google Knowledge Graph MID for it. And then that way we can skip between logos. But more importantly, logos are very useful for detecting films that are about the same subject. So you can see here that it actually doesn't, this is a cartoon, this film, and it doesn't care. It still manages to recognize things and logos and so on in cartoons just as well as it does in live action. So I've gone into kind of some detail about the data that VI provides to allow us to navigate around films and to search through them, etc., by their content. But the most interesting part for me is being able to use all that for film disambiguation. And that's to say, knowing that film A is a duplicate of, or perhaps similar in many ways to film B, because that's actually quite a difficult task to achieve if you try and do it digitally. So what we found is that using the content of the film that's been discovered by video intelligence allows us to compare films that we otherwise wouldn't be able to compare. So here's the problem about trying to do it digitally. If you take the digest of 2 video files, it will only show you that they're the same film, as if they're clones of each other. So if you've got films in different formats and qualities and different encodings, they're going to produce a different digest, even if the films have got exactly the same content. And of course, different cuts of the same film just simply can't be detected digitally. Maybe perhaps by some kind of soundtrack wave comparison, but then, you know, what about languages? Or with a complex video fingerprint maybe. But that wouldn't help identify similar as opposed to duplicate films. And I want to be able to do them both. So we've got loads of content information, as you've seen. So why don't we use that? So here's an example of films that have been detected to have similar content. So this is not duplicate films. This is films that are similar to each other in some way. So the way that it works is that their video intelligence labels have been compared, And we found a high similarity between each of these films. And that's normal because, in fact, they're part of the same ad campaign. So it's good that it found it. And this gives a very useful but completely automatic and maintenance-free find more like this feature. You know, many systems have got find more like this, but usually it's based on metadata, or perhaps if it's something like Amazon, it'll be based on what other people buy that, you know, that's like the thing that you just bought. But this is completely maintenance-free because it's completely driven off the content of the film and not by any manual intervention whatsoever. So how does this work? Similarity detection is actually rather straightforward. As you'll see when we get to duplicate detection, it's a lot easier than that. So the labels detected at each shot change for all the films that we know are compared with the target film. And then they get scored on how many objects that match that are found at each point. So if you look at this part of a film, just the first 3 shots of a film, we're seeing 3 shots, and at the beginning of each shot, we've detected that there's a chicken and a cow, the first shot, a chicken and a balloon at the next one, and a person and a chicken and a cow and a pig in the intervening frames between shot 2 and shot 3. Now, if you recall, a shot is going to have many frames in it, and each of these frames have got labels associated with them, as well as the labels that were detected at the beginning of the shot. So really, the most important labels are the ones at the beginning of the shot, and the less important ones are the frame labels that happen in between. So now I've got a great way of trying to find other films that have got a configuration like this. So other films that have got the same sort of content, especially at the shot change markers, and especially things that happen in between shots. So other films with chicken and cows are going to score pretty highly. The text, transcriptions, and detected logos are all going to enhance the score. So if I find 2 films that have both got the same logos on them, that's a good clue that they're similar. And all the intervening frame labels add incrementally to the score of films as well. So you put it all together, and it's actually becomes quite straightforward to find films that are like each other. So the algorithm we're using for finding similarities is tunable to points between content bias and thematic bias. So content bias tends to return commercials that are all about the same kind of brand and product, whereas thematic biasing returns commercials that are similar in setting, style, and activity, and tends to return films that are alike in more subtle ways. So this example is more biased towards content, the first way of matching. So it returns a set of commercials that are mainly about beer drinking, the same as the film that we're matching against. So these films are all pretty much about beer, and they're mainly about Stella Artois, I believe. So you can see that it's looked at all the labels and seen people drinking beer, it's seen logos that matched, it's seen dialogue that's been the same, and it said, yeah, these films are all kind of the same. Now, using a more thematic bias, and we get some, I would say, rather more satisfying subtle matches that together make quite a nice collection. So in this group, the source film is a film about beer drinking, and it features some jangly piano music, a bunch of priests dressed in black and white robes running around in a monochrome wintry landscape. Now, the proposed matches that we've come up with here have similar piano music. They're black and white costumes or images, crowds of people or objects moving around in a similar way against a very bleak background, but they're nothing to do with beer. So this is the difference between a thematic comparison, which is about things looking the same, having the same feel, and a content comparison, which is about strictly things that are the same subject. So really, I think the right, depending on what you're trying to do, what your objective is, I think probably the nice comparison is somewhere in between the two. So we've looked at films that are similar but not duplicate. Now, duplicate content is harder to detect. Similar films are easy to match. You've got the VI labels, you just count them. However, detecting duplicate content is really much harder. So take a step back, and why do I care about duplicate content anyway? So this example has a whole series of different cuts of the same film. Different versions need to exist for different markets, the length of the advertising spots, the languages, etc. The person who uploaded the film, the director, the actor, the director of photography, or whoever, might have cut it differently to highlight some aspect of their performance. So we're going to end up with a whole bunch of different films that are really the same film. They're going to be in different orders, different lengths, potentially jumbled up in different languages, all this type of stuff. And the task is to identify that they're not just like each other, but they're actually the same duplicate content. So on uploading that, we need to know if it's a film we already know, because we have a host of film metadata such as cast and crew and everything else that we need to share between the various cuts of the same film. And detect the film isn't actually new, but just another cut of an already known film. So this is an example of 3 different versions of the same film that were uploaded without duplicate detection. So the difference between them is that they have different edits, they're different lengths, they're in different orders, but they do have enough duplication between them to be detected as the same film. So really they should be merged into a single film, their metadata consolidated, and for them all to appear as options when you find this particular film. So that means that we need to update the workflow that I referred to at the very beginning of all of this. And the extra step that we need is this deduplication process. So you upload the film, you do all the stuff that we did before in terms of running it through the Video Intelligence API, organizing the labels, cutting it into segments, etc. But then we look for duplicates, and then we say to the user, hey, this is a film that you've seen that we already know. Is it this one? And then that'll be the invitation to merge it with an existing film to avoid us having a spread of films that are actually the same as each other. So to summarize the way that we do duplicate detection, if we see the same objects in the same film segment, for example, a person, a dog, a flying saucer, and a balloon, it's a clue that there could be some duplication, but it's only a clue. And of course, common objects such as a person attract much less weight than an uncommon object as a flying saucer, for example. But if the dog, the person, the balloon, and the flying saucer move through the same relative positions in the segment, it's an even bigger clue. So if you've got a dog at the top left of the screen and a person at the bottom right and a balloon at the top right, and you've got another film that's got the same 3 objects in the same places, that's a bigger clue. And then the level of confidence actually plays into this rather importantly as well, because the way that video intelligence works is it applies a level of confidence that what it saw is really what it's saying that it saw. So if it's at 90% confident that it's a dog, it's probably a dog. If it's 20% confident that it's a dog, it could be a squirrel or something. So really, by noticing 2 objects that are both classed as being dogs in the same position at the same time as something else that's classed as whatever it's classed as, at the same level of confidence, then you've really got a pretty good idea that this segment that we're looking at, the segment of film we're looking at, is exactly the same as the one that we're comparing it against. So if you get enough segments like this with all the same stuff in the same order, then that's probably duplication. So if we now tweaking the algorithm can be quite tricky, and it's in early days yet for us, so it still needs a little bit of fine tuning. So we've added animated object tracking to help refine it. So those little pink boxes that you see on the film, it says clothing, person, and bottle, they're actually animated, and they are showing the objects that were detected at that point. And so if you play the film the whole way through, you see all that changing and things that it found. And the size of the box and the position of the box is the center points of the bounding boxes of each object that it found. So during the time of this segment, however long it lasts for, the center of the bounding box of that bottle will have moved through those positions that the little pink square is on. So that's our trigger points, if you like, or our anchor points for noticing that we've got the same object appearing in the same place, so we can compare each segment. So this is what it looks like when it's broken down. This is a film with 4 shots and 5 segments. So notice that one of these shots is split in 2. So it's a Y. Well, because sometimes a film contains a very long tracking shot. Indeed, some films are just one continuous shot. So it wouldn't work if we were just to treat the whole thing as one segment, because then every single object in the film would be in one segment. So we have to either break the film up at each shot change, at each scene change, or alternatively, we have to take long shots and cut them into bits. And then that way, we've got some chance of noticing the coincidence of objects and their position as the film's going through. Now, if a film's edited to a shorter version, the cuts are likely to be made at scene changes, except in the case of the long tracking shots, obviously. So it's always important that we preserve those scene changes. It's less important where we put the breaks in long scenes. So each segment notes the object and the positions in the shot they were observed at. You'll see in the little screenshots at the bottom of this slide, you'll see the little pink markers that show where the object was seen and where it moved through during the course of that segment. An object that match in entity ID, confidence, and fall within the bounding box and coexist in a segment with other matching objects in the same condition contribute towards a duplicate score. So, since films are being examined in small segments, not dependent on time or order, entirely differently edited versions of the same film can usually be identified too. So in this example, the 60-second, 90-second version of the same film have been identified as duplicates because we found enough segments in there with coexisting and co-occurring objects to give a clue that actually it was the same film. So now we can just ask the UI to merge them and share their metadata. So I mentioned that some films have got some really long shots. This particular one has only got one meaningful shot in it that lasts the entire 60 seconds of the film. It's actually a film about a guy on a bike who's cycling through some city neighborhoods and stopping at shops and bars and talking to people on the way and everything. And it's being followed by a camera, so it's a single one-shot film. And because we split it into shots, we're still able to benefit from the people that he meets on the way and where they are relative to each other, which we wouldn't be able to do had we not split it in the first place. So I'm getting towards the end. So just for completeness, this is how the whole thing fits together on Cloud Platform. So there's 4 stages. Upload the film first. Check for digital equivalence, move the film to Google Cloud Storage for archiving and labeling. So if the films are digitally equivalent, then we're done. If they're not digitally equivalent to something we already know, we have to go through the process of analyzing them and comparing them. So we start the analysis process, we populate our database with the results. We add the film to our Elasticsearch index pipeline, so that eventually becomes available for comparison. And then we execute that disambiguation process and invite whoever uploaded it to say, yeah, that is that same as that other film, so yes, you can merge it. And then now the film content is available for search and navigation. So that's the end, but I do have one cautionary note to all of this. If you are thinking about using the API, it's a great thing. It's pretty easy, but it's pretty easy to rack up high bills. So depending on which feature you select, a 1-minute commercial will cost you about $1 to process, which may not sound a lot because you do get back a truckload of data. But if you're embarking on a project, then you have thousands and thousands of films to retrospectively analyze, as we have. It can be quite a financial challenge to take that plunge. So anyway, that's video intelligence and how we use it. So thanks for listening. I hope I've given you some insight into how useful the video intelligence API has been to organizing the content of our films. And I'd love to hear about what you're building. And I'm sure you've got my contact details on the speaker page, so I'd love to hear from you. And that's all.
Yeah, really interesting. Thanks a lot, Bruce. And yeah, I was thinking about how we can just take more advantage from this thing. And I was thinking of the problems of the fake news. So let's say if somebody has posted a small clip, maybe 1 second, 1 minute, and so can we somehow get the intent or get the context behind the clip if we tag the clip appropriately?
Yeah. So I missed the beginning. I didn't have my headphones on. Could you just say the first bit again?
I mean to say that if we can use it to solve some of the problems with the fake news or something like that, maybe somebody posted a clip, a very small clip, maybe of 1 minute or 2 minutes, and can we if that clip was tagged appropriately, can we get the context behind that clip?
Yeah, indeed. In fact, there's already quite a number of sites that are doing this. They're doing image searching, using the Google image searching tools to find internet-type stories about things that are in a video, and consequently, is that what you really said, and so on. So there is that happens. I think the issue with the video intelligence thing is it's quite a process to do. I mean, it's if you got a minute film, it will take a minute to analyze. So you can't analyze everything out there in the hope that you might find something. I think you need to be very specific about targeting what you're looking for. But yeah, it certainly is an important opportunity to help combat this fake news virus that we have.
Yeah, Shadab, I think you're muted, but yeah, it makes total sense.
Yeah, I wasn't muted. Yeah, thanks a lot, Bruce. And thanks a lot for joining us. Maybe I'll now bring our last speaker of this slot, and last but not the least. And okay, so yeah, we had some really nice conversation about the intelligence, a lot of things. But let's just change the direction of the talk a bit, not too much. Just let's focus more on the infrastructure side of things. So our next talk will talk about building, training, testing, deploying, and monitoring a machine learning model. And the title of the talk is DevOps for Machine Learning, Deploying ML Models at Scale on GCP. So Vasudev Maduri will be giving this talk. He's a machine learning engineer. He's a cloud evangelist at Hitachi. And his past works are related to IoT on Google Cloud, deep learning, and cloud computing. So Vasudev, all yours now.
Yeah, thank you. Can you see my screen, right? Yeah. Yeah, so a bit of introduction about me. So I work as a machine learning engineer at Hitachi back in India, and I primarily is an active speaker and also active speaker and also a DevFest speaker like last year too. And so today let's start about the DevOps and MLOps side of it. So often we do write a machine learning model and we just stop at a point wherein we couldn't move over a Jupyter notebook or a Python file or right out of on-prem. So we cannot actually productionize the entire machine learning model. So in that case, what exactly we need to do? So how exactly it needs to be done? So we'll just see that today. So have you ever came across this situation? Probably the entire team wants to deploy the model right on the production environment. So how exactly the roles are defined in an industry, and like a data scientist wouldn't be deploying a model to be precise, but yes, there are some roles called MLOps engineer and ML engineer who does the end-to-end job, and nowadays full stack data scientist is also something which who does the entire job from end to end. So if we talk in that perspective, a data scientist cannot actually do the entire job. So in order to automate or reiterate the entire things, that's the reason why MLOps has been evolving. So this is what the traditional machine learning model design is, wherein we collect the data and pre-process or transform the data and do it model training and evaluation of the model, and then prediction, and then deployment. And this is not a one-time job. This is an incremental job. And as we move on in time frame, we actually do it multiple times, and we need to do that because we want to get the most out of the model. So that's the main scenario why we actually go for retraining and revalidation of the model. And when we speak on a different perspective, wherein we have if any particular point here changes, like if the data changes or the model changes or the code changes, we need to actually reiterate the entire flow. For suppose I have trained on a set of data which can't be predicted, like after 6 months there could be a new set of data objects or data points. How exactly the model can handle? Of course, it can handle. Yeah.
Vasudev, can you hear me? So sorry, the slides are showing in presenter mode. If you can just put them full screen, that would be nice.
Okay.
Yeah. Just try to, yeah.
Is it fine now?
Try to reshare the screen. Yeah, it was, yeah, hard to see the letters and all that. So yeah, make sure everything looks clean. Try to reshare your screen again. Yeah, that works. All yours. Yeah.
Yeah.
Cool.
So in each and every step, we need to actually reiterate the entire model. So in order to achieve this, like in a different time frame or in a short timelines, we generally go for like MLOps. So in a traditional software development, we have something called DevOps, and in the security terms, like we have something called DevSecOps, and in the same way for entirely managing the machine learning lifecycle, we have something called MLOps. So let's actually dive into that. So it started back in like early 2000s, wherein the MLOps and DevOps have actually picked up, and currently each and every machine learning model platforms are kind of microservice, and they are Dockerized, and they have been deploying on top of Kubernetes, right? So in this entire chain of development of machine learning models, we have started from a place where we have only used like Python scripts, but now we have moved to a place that we are deploying the machine learning model as a microservice. So that's a large transition in the way we productionize the machine learning model. So let's see how exactly we can achieve that too. How exactly we can deploy a machine learning model as a microservice. So machine learning pipelines are something which are not easy. So generally, if we take a case, if we want to productionize a single machine learning model, it has multiple versions, around 100 to 200 versions, and we need to manage each and every version. For suppose if we move to 150th version, and if I want to reiterate or reinitiate the process right from 90th version, I need to do that. So how exactly I can? So that's what the flexibility which is provided by MLOps. So MLOps is nothing but the combination of machine learning and developer operationalization, wherein we experiment and we get the data, and we have people from multiple domains like domain experts, and also we do work with the infrastructure people out there, wherein we get the continuous delivery and model monitoring. So there is certain gap between all the stakeholders out there, wherein we have a data scientist, we have a core software developer, and we have an infrastructure engineer, and also on top of all these people, we have a product owner. So how exactly one can manage the gaps between that, and what exactly causes the gaps? So let's see that. So the main gaps out there are the composability and portability and scalability. So let's see each one of them and how exactly it matters when it comes to machine learning lifecycle. So generally we have multiple steps out there to build the model, right from data ingestion to model deployment. We have like steps like data ingestion, data analysis, transformation, and training the model, and rolling out and evaluating and serving the model. So generally, this doesn't happen in a single mission, or this doesn't happen with respect to a single person. Multiple stakeholders do involve in this. How exactly that needs to be handled, right? So generally, it happens like on a single laptop, or a data analyst might transform the data and keep it aside, and data splitting might be done using the help of a database engineer, for example, and training the model and like model validation might be done by a data scientist or an ML engineer, and rolling out and serving the model might be done by the release engineer or a DevOps engineer, and monitoring and logging might be done by a different people out altogether. So how exactly the flexibility between all these systems would be managed, and how exactly the communication would be streamlined between all the stakeholders. So that is one more reason why we go for machine learning lifecycle management. And when we go for microservice type of deployment for MLOps, this can be achieved. And the next thing is scalability. So oftentimes when we actually grow up with the amount of data with a specific timeline, like for 6 months, my data can be actually grown up to terabytes to petabytes. And in that case, I actually need to have my hardware ready, my infrastructure ready to train the entire machine learning model. I cannot actually put a hard limit on the infrastructure. I need to be ready for whatever the data which is there in place, right? So for that particular reason, we have the scalability issues. And when we go for cloud, when we deploy as a microservice, we can achieve the high availability and scalability according to the model. So that is one more like a takeaway wherein why we go for the microservice kind of deployment. And the next thing is portability. So in generally, what exactly happens is we develop our models on laptop, right? Like developing the model code or algorithms on our laptop, and then that means all the steps happen in the laptop or a system. Then the next would be the training of a model. So training of the model happens in the training rig, probably on the cloud or on-prem servers, but not exactly in the laptop in the real-time cases. And next, why exactly cloud is there in place? Because we need to provide 24/7 availability of the model serving. So for that case, we have cloud in place. So when we actually go from laptop to cloud, or model development to deployment, so the entire steps involves many different types of environments. If environments, I mean different types of OS, like the laptop might have the Linux system, probably the cloud have Windows system. So generally we do check that, but if there is any hard rule out there, we cannot actually move the model from Linux to Windows in some cases. So in that case, how exactly that should work? So in that case, if we containerize our model and then deploy it onto the cloud, so that's a good approach. So we'll see how exactly that can be achieved. So model serving as a microservice, wherein we have a training phase and we have a prediction phase. So here we have a model builder and feature extraction and training data, wherein the entire development phase, we'll create an artifact in assume in the form of a Docker container, and after evaluating and reiterating the model, we just push the entire model container to the deployment phase. So that would be the ML model, feature extraction, and REST API. So when a container is deployed and it is available on top of a REST API, and whenever the client requests that particular REST API, and that model gives the inference. So it's simple in terms of management. We all know that the model development and deployment is nowadays very important, and the most unseen or overseen part in the entire development is model productionizing an ML model, and that takes like much effort out there. So in order to reduce the effort, what are the tools out there, and what are the frameworks which can actually be used and reduce our work of deployment? We'll see that. So from now on, we'll talk about the containers, wherein each and every step in the entire machine learning lifecycle, right from data ingestion to model deployment to model logging and monitoring, we categorize each and every step into a container and as a microservice, then deploy it onto Kubernetes, right? So this way, the entire chain of the models would be in place and the lifecycle can be managed. So this is the entire spectrum of frameworks available out there for all the machine learning and AI capabilities, right? And the most frequently used platforms for machine learning development or management are Kubeflow and MLflow. These are one of the popular ones out there. All these are like the open source ones and the most used ones, but out of that, when we go for Kubernetes and when we go for microservices and when we go for a deployment on top of the containerized deployment, then we go for Kubeflow and MLflow. So in this particular session, I'll concentrate on the Kubeflow, wherein how exactly you can start off with that and how can you deploy the machine learning model on top of that. So how exactly machine learning workflow works? So we can check like each and every step out there. So as we know, the data engineering is the core part, and 70 to 80% of the work goes in there for cleaning and transforming the data, and then model engineering and code engineering. Let's talk about model engineering. So model engineering has like model training, model testing, model evaluation, model packaging, and model deployment. And when we say training, the training can be on any infrastructure, and testing is something called validation against the expected output, and packaging is something wherein if I want to deploy the model onto the edge, I need a different packaging altogether. If I want to deploy it onto the cloud, I have probably like PFA and open neural network exchange. That is one of the format which we deploy the machine learning model, and finally the model evaluation once we deploy. And the second one is model serving, monitoring, and tuning. So whenever the data changes, we need to tune our model to get the best optimized results out there, and that is very important going forward once we deploy the model. And the next is code engineering. Code engineering is nothing but we have a core software product, and we want to integrate some of our AI features into the that particular module of the entire platform. So in that case, the code base of both the platform and the machine learning code needs to be merged at some point in time before we go for production. So how exactly that is managed, how exactly the versions of the machine learning code is managed. So that is also an important aspect of the entire end-to-end machine learning workflow. So in order to achieve all this, this is an open source framework, again, Kubeflow. We can achieve all the things which we have discussed till now. And this is an open source framework from Google, which actually used for develop, deploy, and manage the distributed and scalable ML systems on Kubernetes. And this can be actually deployed on prem like a native deployment, or else on the cloud, which is cloud agnostic. It may be any cloud out there. It's not specific to Google Cloud or AWS or Azure or Oracle. It can be on any cloud. Right. So going forward, we'll discuss about Kubeflow. So Kubeflow is mainly used for all the stakeholders out there, because each and every step in the entire machine learning lifecycle is done by a different stakeholder, to be specific, right? So in that particular point in time, the Kubeflow can be used by all the data scientists or ML engineer or a software engineer or the product managers too. And the next is it's actually portable on ML products, wherein we can deploy it on the mini cube or mini version of Kubernetes on the edge devices, for example, edge TPUs, or else we can directly deploy it on the top of Kubernetes. If we take, for example, of Google Cloud, then we deploy it on top of Google Kubernetes engine. And it has a great community out there, and it is developing at a rapid pace. So its current version is 1.1, and the entire platform is used for managing the machine learning lifecycle. And why exactly we need Kubeflow? So till now we understand that we need the MLOps, right? So why exactly we need to go for Kubeflow? So whenever so just an analogy wherein the entire platform code is on the containerized deployment pattern, but I want to also, in that case, I also want to deploy my entire machine learning models in the same fashion. So in that particular case, I probably go for Kubeflow because it supports the microservice architecture of machine learning management, unlike the different frameworks out there. So Kubeflow pipelines are something which is a component of the entire Kubeflow framework. So Kubeflow pipelines are mainly used for the chaining the entire machine learning pipelines, like end-to-end orchestration of machine learning pipelines. And coming back, the Kubeflow has multiple components out there. It provides an UI wherein we write and control all the machine learning jobs from that point. And we have something called ingestion, preprocess, trainer, validate, and serving. These are the internal components out there wherein I can control all the machine learning aspects of the entire lifecycle. And coming back, the Kubeflow pipelines. So Kubeflow pipelines are something wherein I can actually orchestrate or draw a directed acyclic graph of the entire machine learning tasks in a sequential manner or a parallel manner according to the use case, right? As you see here on the right hand side, this is a sample Kubeflow pipeline wherein first I'll create a cluster and then analyze, transform, predict, and train the model. And then I'll have some metrics like ROC curve and confusion matrix. So this is a sample Kubeflow pipeline, how exactly we build that. So after seeing and knowing about the Kubeflow, so Kubeflow is nothing but a layer of abstraction on top of Kubernetes for actually managing the ML workloads. So if we see the traditional Kubernetes and general applications on the left hand side, we have something called infrastructure, and then containers, and then the Kubernetes and general applications deployment. In the same way, the Kubeflow is an extra layer added on top of the Kubernetes, and then that enabling the entire management of machine learning lifecycle. So I'll probably also show a code snippet how exactly we can take the model right from the Jupyter notebook to the Kubeflow deployment. So this is the architecture of Kubeflow. Probably to keep it short, here we have something called notebooks and pipelines and orchestration and metadata. So whatever the code which we write in the Jupyter notebook can be actually packaged as a container and can be deployed using the kubectl command, and that creates a pipeline. So here, as we see, the metadata layer is what maintains the entire metadata of the containers. For suppose the container would be saved in Google Container Registry in case of when we save the container to GCR, right? So in the same way, the metadata handles the infrastructure and the service type and all the configuration with respect to that particular task and the container of that particular task wherein it's saved. So that's how the metadata layer helps in, and orchestration is something which is used to chain the entire end-to-end model deployment. So going forward, we have something called job operators too, wherein if I want to deploy my ML workload in a clustered architecture, how exactly it works. So in that particular point, I can create like a couple of nodes out there and have a master node and some worker nodes, and that can be achieved through the job operators on Kubeflow. Although this particular architecture is followed in the extreme cases wherein I need to train like multiple jobs at a time based upon the data. So that's how when we go for the job operators. And coming back, as we have seen this earlier, as I have said that this is the important step wherein we develop the model on the laptop and train the model somewhere on on-prem VM or on-prem cloud, and then we go for public cloud or private cloud for deployment. So in all these cases, we have something in common wherein we can have the Kubernetes as a common layer, wherein on-prem also we can have a Kubernetes layer, and we can start building the machine learning model on top of Kubernetes as a container. So going forward, in that case, when we go forward from laptop to training rig and cloud, the entire manageability of the model would be minimized. So in this case, like independent of the particular state where I'm in, probably if I'm in laptop or cloud or deployment or development, Kubeflow can handle each and every case seamlessly. So that's the main reason why we go for Kubeflow. So coming back, we have something called notebooks too, wherein we can provide and build and train and serve the entire like Python Jupyter notebooks. So when we actually create a Kubeflow cluster on top of Kubernetes, we get an UI, and according to our configuration, we can create a notebook server and start writing the code and package it. So the next is Kubeflow solution, wherein so for example, I want to create a simple NLU model wherein I need to prepare a data, which would be a first step of data engineering and training the model and evaluating the model. This would be a step of model engineering, and then export the results and deploy the model. So this is an extension of both the infrastructure and the model deployment. So in this entire case, as you see, let's assume the prepared data is something done by data analyst, and this particular second step is done by a data scientist, and the third and fourth step is done by an ML engineer, and the fourth step is done by a particular infrastructure engineer. Assume that to be involving 5 different stakeholders out here. If we have a manual deployment out there, how exactly this can be handled, right? It might be sound very hard when we actually do it with a manual deployment, because each and every stakeholder here need to actually go in each step, and the output needs to be given manually to the data scientist, or he can actually put the entire output at some particular storage area wherein from that the next stakeholder can pick up. But when we move forward, or when we actually scale up to multiple versions of models, or multiple number of models for each problem statement, or the number of problem statements increase, that is not a ideal way to productionize the models. So in that case, I go for Kubeflow, because that's a approach wherein I can reduce my manual work, and I can also reduce the entire reiterating or rework which incurs whenever I change my model or whenever I change my data. Next is we can build multiple layers or multiple chaining of branches out there of pipelines, and then we can have the operators out there. Like if I want to save the data or export the data to some particular object storage or BigQuery, I have operators which are provided natively to Kubeflow, which I can use and export the results. So this is a basic code out there wherein I'm writing a particular model under a future underscore prediction code function, wherein I have created a model and then fitting the model out here and forecasting and returning the result as a data frame, right? So this is a basic model assumed. The main idea behind this is just want to explain you how exactly we can use the Kubeflow to automate the process. So here assume future underscore prediction holds the entire machine learning model, and coming back I can use the Kubeflow pipeline components, wherein there is the inbuilt method called function to container operates OP, which is operationalization, wherein this entire function to container converts the future underscore prediction function. So future underscore prediction function holds the machine learning code. We all know that. So that code is packaged into a container, and that is held in future underscore prediction variable. And moving forward, I can actually write a simple YAML file wherein I'll actually import the DSL.pipeline. Here I am constructing a pipeline wherein the name of the pipeline is prediction, and the description would be a method used for forecast. And here I'm mentioning the definition of pipeline, wherein I have a prediction task wherein future underscore prediction is the container. It accepts 3 variables out there, and for suppose if I have steps after prediction, I can write like task 1, task 2, task 3. I can chain the multiple tasks out there, and the compilation of the pipeline. So after building the pipeline, we need to save it in a compressed format and then need to deploy, right? So compile gives us the compiled format of the entire container Kubeflow pipeline task, and then we can actually deploy. And pipeline execution is again a single line of code wherein client.run pipeline, the experiment ID. Experiment ID can be incurred from the here, wherein when we create an experiment to actually execute a pipeline, so it creates client.run pipeline, experiment.id, run name, pipeline, and file name and arguments. So here it's straightforward that we have a machine learning model on top of which we have wrapped it into a container, and that container is acting as a task in the entire Kubeflow pipeline chain, and that task can be replaced individually. For suppose, assume I have a new version of machine learning model needs to be released next week, early next week. Then in that case, I may not change the entire pipeline right from task 1 to task 10. I can just pull down the machine learning model training task, which needs to be replaced, and then spin up the new version. And I can retain the version out there with the previous version because that is retained as a container, right? So that's flexibility is provided by Kubeflow. And how exactly I can deploy the container using Kubeflow? We need to write a configuration file, and again, when we actually use TensorFlow for development of my model, I can download the TensorFlow package, and I can generate a namespace, wherein namespace is something which hold all the set of machine learning like pipelines. And then I can apply the default Kubeflow core, which is actually used to deploy a Kubeflow pipeline. And the next is, this is not exactly limited to TensorFlow, right? You might be thinking like this entire Kubeflow framework is something which is open sourced by Google, but this is not like permitted only for TensorFlow. This can also be used for PyTorch and also scikit-learn and the different frameworks out there. So if I want to use sklearn, wherein my entire machine learning model is developed in the sklearn framework, I can directly install Kubeflow sklearn and do the same job as if I have did for TensorFlow. So the main aim for me to put 2 different slides is, this is not a framework dependent or the language dependent too. We can use Java or JavaScript or Python, anything to actually develop the model. But generally we just use Python for that, and we can use any framework, because as we are using a container, for suppose I have the entire data analysis part in R language and model training part in Python. How exactly I can manage this without a orchestration tool or without Kubeflow? That can't be there. That needs a different platforms or different level of abstraction, which needs to be heavy lifted by the developers. So that particular heavy lifting is being overcome here, because we can have a separate container which has the R environment in it and all the required packages to execute that particular code. For suppose if we move on to the machine learning training step, which is written in Python and which is written using the TensorFlow. For suppose moving on, the evaluation part is written in PyTorch, which is not the actual case. Just assume or just imagine. So the same Docker environment can be configured or can be loaded with the PyTorch environment files, and then all the dependencies of the code, and it can be executed. So that's very easy or very flexible when we go for Kubeflow. So that's all from my side. Wherein so these are some of the resources for all the Kubeflow pipelines and the code labs. So whatever I have discussed here are part of the code labs out there, which is provided by Google Cloud. You can actually refer using these links, and you can connect me or LinkedIn by scanning this code. Yeah, thank you.
Okay, excellent, Vasudev. Thank you so much. Yeah, excellent talk. I think DevOps is extremely important in machine learning. It's how to deploy, maintain, and change, tweaking things, determine, I mean, what needs you have without having to change the whole pipeline. It's very useful. And yeah, so it's a very interesting talk. So thank you so much for joining us today. And yeah, excellent.
Yeah, thank you.
Thank you. Have a great day. Okay. Excellent. So we'll now go into a small coffee break. It will be 25 minutes since we were a bit longer that talk. So yeah, enjoy a little bit of coffee, and we'll see you back soon for the next couple of sessions.